Hello, everybody. Audio is fine for everyone. Just a second, everybody. Okay. So audio, video, everything is perfect. Can I let me know through the chat box? Yes. 1 second. Everybody, please give me a second. So sorry for delaying the class. Okay, I think we are late for 2 minutes. So guys, I can understand all your concerns. Before that, எல்லாருமே எப்படி இருக்குங்க? Everyone is good, safe இருக்க, happy இருக்க. Safe இருந்தா you should give me a thumbs up, and happy இருக்குனா you should give me a heart. Okay. So this will be like 3 to 4 hour session da. We will be completing current electricity chapter. Yena in the chapter 1 the high weightage chapter. Okay, Pradeep, we will be discussing that chapter on Sunday. Okay, don't worry about chapter 2. Okay, also inneki vanda I will be doing a 10-minute session. So on the chapter revision vanda 10 to 15 minutes la na finish panna poren. So adu vanda inneki evening kulla you will be getting it. Okay. We will do, Nantakumar, don't worry, okay? Don't worry, we will do all the chapters, everything before your exam, okay? So, if possible, I'll give you a schedule tomorrow. What are the things, what we are going to do, everything I will be discussing in the, I'll just share in the schedule, okay? Fine, everybody. So, I think this Sunday, everybody is getting, consciously waiting for the physics class. Okay. So start panalama. Everybody is ready. If you're ready, give me a thumbs up in the chat box, please. Ritu, I have already mentioned chapter 2 we will be discussing on Sunday. Okay, Sunday we will be conducting all chapter revision. So on the time we will be covering the chapters. And you don't have to worry about anything. We will cover all the chapters before your exam. Okay, next Monday we will be finishing all the chapters. Adukapra we will be conducting PYQ sessions and expected question series. Okay, that is enough for you guys. You will be getting 60 plus marks. No confusion, nothing. Okay, everybody is ready. So those who are going to give the like, please like, as well as we are going to do a lot of things. So for that you should subscribe the channel. Okay, so I will be starting with the class now because we are already late. Okay, so in the time in the 1 minute kuda romba important irukke. Okay, so hours patti kavalaye padada. Okay, we are going to study. That is what you want to know. Okay, and in the session we will be solving PYQs as well. Recent questions tha. Also, I'm not going to deal with the easy questions. I think you people can do it. I will tell you these are the type of questions coming in that. We will be doing moderate to difficult level questions. Adu mattum in the session we will be covering. Ana PYQ session separate pannumbodhu easy, moderate ella type questions we will be covering them. Okay, so now let us go for the session. So current electricity as I mentioned, everybody, what to say that the award night la Rishmika sonna madri ellavarkume theriyra vishayam da. Enna andha vishayam? Enna andha vishayam? Idu vandu high weighted chapter. Okay, approximately, not approximately, minimum 9 marks. You will be getting a minimum of 9 marks from this single chapter. That is why I am taking current electricity now. Okay, in the next class we will be going for ray optics. Ray optics vandu innum important ana chapter. 12 marks ku and the chapter la irundha questions varum. So in the next class I hope it is on Tuesday evening we will be having the class. So guys, you should attend the session and we will be discussing most of the previous year questions in that session. So guys, please come on time and we will finish ray optics and wave optics in that session. So ipo vanda we are going for current electricity. Current electricity la first topic vanda of course current da. Okay, so what is current? Current na very simple. Okay, current na very simple. What is current? Tell me, what is current? The flow of charges, right? The rate of flow of charges vanda we will be call it as current. Okay, so conductors la vanda in the flow of charges, the charges vanda electrons da, yena conductor kulla free electrons da mattum da irukku. Okay, ipo vanda if we are just talking about electrolytes and all, it will be having ions as well. That is also ions also can move. Okay, semiconductor la vanda we already studied. Okay, again we will have a revision. So on the chapter la we have studied about the free electron as well as the holes. So semiconductor la vanda in the charges na, or the reason for current na, we will say it is due to the flow of holes and the free electrons. Okay, so current vanda rate of flow of charge. So adukku we need a equation on the very simple, the charge divided by time. Rate of flow of charges. So unit second la evlo charges flow pannu. That is what current. Conductors la vanda in the charges na free electrons. Purinjida, everybody understood? Okay. So next vanda we should know the unit of current. Okay. Unit of current na everybody knows it is nothing but ampere. Also we know charge na coulomb. Right, last chapter la we already studied charge na coulomb, time na second. So we can also go for coulomb per second. Understood? So in the current ku vanda we know the equation Q by T, unit vanda ampere, or we can say coulomb per second. Okay, adukapro we should know what is instantaneous current. Okay, instantaneous current na அந்த வேர்ட்ல இருக்கு அதோட மீனிங். Instantaneous current na அந்த இன்ஸ்டன்ட்ல இருக்கிற current. Okay, அந்த particular timeல what is the current, அதுதான் instantaneous current. அதோட equation வந்து we know if we are taking a small time interval, there will be a small amount of charge will be flowing through. Okay, நாம இப்ப எடுக்க போறது instantaneous na and the time interval vandu sinnada, like it is going to be very 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 small. Okay, instantaneous current illa instantaneous na delta t almost tends to 0 anta alavukku, that much small. So delta t tends to 0 means that is what dt, small time interval. So ipo vanda we will be get to know I is equal to dq by dt, and the small time la irukra small charge flow da dq. Ipo vanda we should know about some of the graphs. First vanda ipo na I will be doing charge versus time graph. Okay, charge versus time graph. Charge vanda y axis la, t vanda x axis la. Ipo vanda I wanted to know what is the slope of this graph. Can you tell me in the chat box what is going to be the slope of a QT graph? In the cute graph oda slope enna? Please let me know in the chat box. In the cute graph oda slope enna? QT graph. Very simple on a question. You can answer in the chat box. Very good, very good, very good. Ritu, very good. So, slope na delta y by delta x. So, here we can just see that the change which is happening with the charge divided by the time. So, Q by T na current. Okay, very good guys, very good, very good, very good. Super, super. Okay, so we got the slope is Q by T. So now, I'm just rearranging this one. I dt na dq. I'm just cross multiplying this. I dq na dq. Sorry, I dt na dq. So, இப்போ வந்து எனக்கு வந்து total charge தெரியும். அதுக்கு I will do integration. So, integral I dt na I will be getting the total charge. Correct அல்ல? Integral I dt na integral dq, or let's say we can say the total charge. அப்போ வந்து integral I dt na என்ன? I dt na அந்த we can just say இது வந்து area under the IT curve. Okay, we know the slope of charge versus time வந்து current. இப்போ வந்து I'm going to plot, let's say இது வந்து current and this is what our time. I'm getting a graph like this. இப்போ வந்து I'm going to find this area, and அந்த area na என்ன? It is nothing but the total charge. Purinjida, everybody. Don't forget to like. Also stay on the live. The total session you have to watch. And almost 1:15 we will go for a lunch break. So you can just have your lunch. Also you can just take a break. Adukapra we will be again come up with the few other topics. Okay, wow. I'm getting lots of correct answers also. Yes, Google, இது வந்து simple-ஆன matter. Okay, நான் வந்து discuss பண்றது current. Current என்ன? The rate of flow of charge. Okay, you also try to say this. Okay, otherwise you are doing something, after some time we will forget this. Okay, rate of flow of charges தான் current. And அதோட equation வந்து Q by T. இப்போ வந்து I'm just plotting Q and T graph. QT graph, when I'm drawing QT graph, அதோட slope வந்து nothing but Q by T. Q by T na enna? We have already studied, that is nothing but current. So, slope of QT graph வந்து current. Okay, adukapra what we did, we understood I is equal to dq by dt. Now I am doing I dt which is equal to dq. Now we know I into a small time interval which is equal to a small amount of current. Appo vanda we should know the total current. Total current na enna? We should integrate. Okay, when we integrate, we will be getting the total charge. Enna, we are plotting I versus T. இதுதான் நம்ம graph. Okay, in the IT graph வந்து இப்படிதான். I am going to find this area. In the area to find the area only we are using integration, right? Okay, that is why we are using integration. So integral of this one, otherwise the area under the IT curve வந்து we will be getting total charge. புரிஞ்சுதா? Okay, Nandini, already we have done some videos about it, so you can watch in the channel. Okay, how to manage February month, because you are focusing on Neet as well as CBSE. So adu vandu konjam difficult tha. Adukku what was the process? Adu vandu we have already done a video. Okay, so now we can expect some questions here. Let's say the number of charges given. Okay, number of charges given. We know, we have to find the time in 5 seconds. Adu the question. Okay, number of charge mattum da we have. So how we will be finding it? Very simple. We know I want the charge by time. In the charge we have studied an equation in electrostatics. Please let me know in the chat box, please. In terms of number of particles, number of electrons. What is Q? What is Q? Tell me, what is Q? It is nothing but Ne, right? E yoda value enna? யோட வேல்யூ என்ன 1.6 into 10 to the power minus 19 coulomb. Everybody got it? I mean, you guys are getting it? Yes or no? Don't forget to like. Also share with your friends. We can study together. Okay? So, we can expect such questions like this. We will be having the number of particles. Time kuda we will be getting it. So, appa vanda current enna. Adu oru question da. Adu vanda simple question da. Okay? Next vanda Q in the format la koduthirukku. Q is equal to t square plus 2t plus 6. இப்போ வந்து எனக்கு தெரிய வேண்டிய விஷயம் current என்ன? What we will do? Let me know in the chat box. ரஃபா பானு கொஞ்சம் தமிழ்ல தெரியும். ஆனா இந்த தமிழ் வந்து அவ்வளோ பெட்டரா இல்ல. பரவாயில்ல அவ்வளவுதான். மேனேஜ் பண்ற அளவுக்கு தெரியும். நான் வந்து கேரளா. I'm coming from Kerala. So Kerala, Malayalam and Tamil was like almost same but different. So I know a little bit. Very good. We will be going for I is equal to dq by dt. Okay. So ipo vanda we are going to differentiate d by dt of t square plus 2t plus 6. Eppadi differentiation pandrathu? We will be giving this to individual terms. D by dt of 2t plus d by dt of 6. Correct ana? So, இப்போ வந்து d by dt of t square na enna? It is nothing but 2t plus d by dt of 2t வந்து 2 and d by dt வந்து constant. Constant க்கு என்ன value வரும்? 0. Correct? Yes or no? If you understood, please give me a thumbs up in the chat box. So, in the question la வந்து current வந்து 2t plus 2. இதுதான் in the segment la they will be asking some easy questions. You can use I is equal to Q by T, which is equal to NE by T. And another question one, the Q is equal to T square plus 2T plus 6. Okay, not consistent la or repeated. This question was not asked, but it is asked. So we should know. That is why I'm discussing this. Okay, if you understood, give me a thumbs up. Thumbs up, please. Tapana, right? Again and again, if I'm pronouncing anything wrong, please correct me, okay? Done, everybody? Yes or no? Yes or no? Very good. Monish, thank you. Smrini. Sorry. Sri. Okay, I'm not reading. I'm not getting it. Rasita. Okay, fine. Okay. Sure, we have. So, இன்னைக்கு வந்து physics, நாளைக்கு வந்து biology, next day chemistry, அந்த மாதிரி தான் session போறேன். Next Sunday onwards, physics மட்டும் தான் இருக்கு. Okay. இங்க you don't have to worry about anything. Okay. So, இப்போ வந்து we have studied about the current. So, இந்த currentல வந்து we know current வந்து rate of flow of charges. And அதோட equation வந்து Q by T. Otherwise, we can write it as NE by T. Next one, the instantaneous current. Okay, that is nothing but dq by dt. So from this, I'm writing slope of QT curve or QT graph. One the current. Adukapro, we will be doing IDT integral, which is nothing but the charge. So in the charge one, we can just write also as area under IT graph. That is what the charge. Next one, we know the unit of current. Unit of current one the ampere illana coulomb per second. Okay, adukapro we know one thing, it is a scalar quantity. Okay, it is a scalar quantity. This is a scalar quantity. Why it is a scalar quantity? Don't forget to like. Okay, why it is scalar quantity? Current ku vanda magnitude irukku, direction irukku. Ana the problem vanda this is not obeying vector addition rules. Okay, இது வந்து vector addition rule obey பண்ணல, அதனால தான் we are just saying this is the scalar quantity because direction இருக்கு, magnitude இருக்கு, ஆனா this is not obeying vector addition rule. அதனால இது வந்து considered as a scalar quantity. அதுக்கப்புறம் we should know the direction of current. So conventionally we will say the direction of positive charges. Okay, what is the direction of positive charges? Adu the current order direction. Okay, the flow of in the which direction in the positive charges flow pandra and the direction the current ikku. So we can say that opposite to electron flow. Okay, very good Ranjit, very good. Okay, so it is exactly opposite in the direction of flow of electrons. Everybody got it? Yes or no? Tell me. Yes or no? Okay, so next one we have to study another one that is nothing but current density. Adu vanda represent பண்றது J. Okay, current density vanda represent பண்றது J. ஏன்னா this is nothing but the current flowing per unit area. Okay, in the equation irundhe you can define current density. Current density na enna? Current by area. Current by area na enna? Current, the flow of current in the amount of current in unit area. Okay, and idu the vector quantity da. Okay, this is a vector quantity. So in the vector quantity na we should specify the direction. So what is going to be the direction of J? J uda direction enna? Okay, because we know we can't write it like this. I can go for the magnitude of area vector. Yena we can't divide any quantity with a vector. Inga vector poda mudiyadu. Appadina we should rewrite like this. Okay, J which is equal to current divided by area. Okay, so in the area vanda vector da, current vanda scalar quantity da. Up in the J oda direction vanda enna agum? Yes, it is having only depending upon the direction of area vector. Area vector oda direction enna? Current ippadi pogudhu. So we can just say that whatever, this is the surface, the current is passing through it, perpendicular to the surface. In the area vector vanda always perpendicular to the surface. Okay, so in the current density la vanda you have to study this term J which is equal to I by area, and the direction of this current density vanda direction same as the area vector. Idu vanda oru vector quantity. Okay, so current density and unit. What is going to be the unit? Current na ampere, area na meter square. So ampere per meter square is the unit of current density. Everybody got it? Yes or no? Yes or no? Give me a thumbs up with full energy, guys, please. Done or still you have any confusion? Very good. Razita, right? Yes, Damodaran. Yeah, Damodaran was in the last class also, right? I do remember your name. Okay? So, pasangala, like panniko, subscribe panniko. You know, we are going to do a lot of amazing sessions for you guys. And physics vandu avlo tough alla if you are studying in a proper way. Okay? Thank you. Okay? So, Ohm's law. Ohm's law vanta you have studied, you have studied in 10th grade itself. So it is not at all a big deal. Ohm's law, it is nothing but at constant temperature, okay, or keeping the physical condition constant. Yeah, I'll tell you later why we are just specifying this. At constant temperature, the potential difference vanda proportional to current. Okay, potential difference vanda proportional to current. When V increases, potential difference increases. current ku enna agum? If V increases, what will happen to current? Quicker, you should give me an answer in the chat box. Let me check who is giving the answer first. V increases, current ku enna agum? Innu faster venuma? Oh my god, I will die. Tell me. Very good, Ranjit. Very good, very good. So, current also increases. Ipo vanda, very good, very good. Super, guys. Super, 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 super. Very good. So, now V increases, I increases. Now, we should change this proportionality sign with the constant. Adukkaga, we are introducing a constant. Adu vanda resistance. Okay, adu vanda resistance. Idutha we are calling it as resistance. Okay, so ipo vanda we can just write V by I, which is equal to R. Okay, V by I, which is equal to R. Now just think carefully. I'm going to ask you a very simple question. You should give me an answer quickly. Okay, think and give me the answer like this. Ready? Yeah, everybody is ready. Ready now? Give me a thumbs up. Okay. So now we have potential difference V. Adoda corresponding current vanda I. Okay, V potential difference, I vanda current, and on the circuit la vanda resistance vanda R da. Okay, R da resistance. Ipo vanda enoda question. Listen, V potential, adoda corresponding current vanda I. Okay, resistance vanda R. Now, I am increasing the potential to 2V. V vanda 2V actually. And the resistance ku enna agum? What will happen to the value of resistance? You should tell me the resistance. What will happen to the resistance? V vanda 2V arku, resistance ku enna agum? Quickly think and give me. Hey, so ivlo time now whatever I have told you, that becomes useless. Eppadi adu twice agum? We just now only said this is going to be a constant. Proportionality ke change pandradhukku we have used the resistance as a constant. So first what I said, V increases, and sorry, V vanda V, current vanda I, and the corresponding current vanda I. Ipo V vanda 2V achu. Okay, potential vanda 2V achu. Appo as per this, the same will happen to the current as well. Correct? Potential difference double na, current vanda double. 2V by 2I. Again we will be getting the same result as R. Yeah, na R vanda constant. Correct. R vanda constant. So according to Ohm's law, V is proportional to I, potential difference at a constant temperature. The potential difference vanda proportional to current. And in the proportionality sign change pandradhukku we have used R as resistance, or sorry, constant. Okay. Appo vanda we can say V by I vanda always constant. So ipo vanda I will be drawing a graph. V I, and the graph வந்து இப்படிதான் இருக்கும். Why? ஏன்னா we have already said R is a constant. Okay, R is a constant. இதோட slope என்ன? If I'm just drawing VI graph, slope என்ன guys? Slope of this graph வந்து V by I. V by I na என்ன? R. R na என்ன? Constant. புரிஞ்சுதா? Everybody got it? இது வந்து ரொம்ப important ஆன concept. Because as you given the answer as 2x twice, that was wrong. Okay, resistance வந்து change ஆகாது. ஏன்னா அது வந்து constant. V increase பண்ணினா I கூட increase ஆகும். Okay, எப்பவுமே அது வந்து V by I ratio வந்து R தான். அது வந்து ஒரு constant value தான். Everybody understood? Give me a thumbs up please. Everybody understood? Yes or no? Yes or no, please? So, இப்போ வந்து we got We got, sorry, yeah. So, now we have seen Ohm's law. Ohm's law na at constant temperature, the potential difference proportional to current, V proportional to I, V is equal to Ri, V by I always constant. Now we are going to see the graph. Okay, as I mentioned, V by I, okay, the other one the slope. Okay, so we have A and we have B over here. Okay, in the case of we have two wires, A and B. Okay, we have two wires, A and B. So, corresponding potential I graph for each wire we have given. In the case of which one is having the highest resistance? Tell me, for A or B? For A or B, in the case of the highest resistance, for which wire? Tamil mix பண்ணும்போது எனக்கு கொஞ்சம் confusions இருக்கு அதனால தான் in between I was just getting stuck. I hope my Tamil is okay, right? Yes or no? நீங்க எவ்வளவு rate பண்ணுவீங்க for my Tamil? I wanted to get the feedback after the class, okay? You should tell me how was my Tamil after the class. I want to see in the comment box. So large, which one is having larger resistance? Which one is having larger resistance? Very good, very good. So, we know slope of VI graph, the V by I, that is what resistance. So, if we பார்க்கும்போது A or B is having more slope, tan theta, the theta increases, right? Tan theta or slope on the tan theta. So when I'm seeing the two wires, I will get to know the tan theta value romba adhigama irukkiradha A. Okay, so the answer purinjida. Okay, purinjida. Very good. Greater the slope, greater the resistance. Very good. Okay. Now I'm going to give you 3 more wires. Okay. In the graph which one is having the highest resistance? Okay. Tell me, in this case, in the second case which wire is having the highest resistance? In the question I wanted to know highest resistance. Tell me which one is having the highest resistance. Check the diagram again and tell me the answer, okay? Changing the answers. Many people, most of you are changing the answer. Why? Yena, inga the slope. The slope in the case in the y-axis what we have marked I. So delta y I. And change in the x-axis, that is the V. Appadina, idu 1 by R. Okay. So, in the case slope adhigamana irundha, that is equal to 1 by R. So, adukku least resistance. Okay. So, in the case the answer A. Yena, the slope is coming as I by V. Purinjida, everybody. My cute Pazinkala, you should tell me, understood what? The 2 different graphs of Ohm's law. Understood? Yes or no? Very good, very good, very good, very good. Okay. Thank you so much. So, those who are coming new, subscribe the channel as well as you should like the video as well. Okay? Done. So, now we are going to focus on the resistance part. Okay. So in the resistance we studied V by I, which is equal to constant. Okay. In the constant in the resistance depending upon few factors. Okay. It is depending upon few factors. First one is the length. Okay, in the resistance directly proportional to length. think length increase பண்ணிட்டேனா resistance increase ஆயிடும் ஏனா resistance na the oppose it is opposing the flow of current, right? Resistance na it will oppose the flow of current. So in the case la vanda we can say that when length increases, okay, you just imagine you are going to a very very rush market, okay, ange like lots of people are there, ange vandu many people are there, okay, appo vandu you have to walk from one end to the another end. So we know avlo aalal irukke, so adinala if you are just going you will collide with many people, okay. So when you go longer distance the collision increases, correct or wrong? Le we are going to a rush market and many people are there, so when we walk what will happen, guys? What will happen? We will collide with many people, collision increases, the resistance increases. So length increase பண்ணும்போது in the free electrons ion oda vida it will just collide and it will go, okay. So the resistance increases. Next one it is proportional to 1 by A. So now imagine suddenly வந்து அந்த row ஓட area increase பண்ணியாச்சு, அப்போ வந்து collision reduce ஆகும், reduce ஆகும்னா resistance reduce ஆகும். So in the resistance order in the question vanditena, because this was asked, resistance depends upon the factors you have to specify. So on the case la vanda you should imagine you are walking on a rush street, okay. What will happen to us if you are going for longer distance? The resistance collision increases, resistance increases, and area increases, which means what will happen? The collision reduces, resistance also reduces. Next one it is also depending upon the material, okay. Different material ku vanda the resistance will be different, okay. Other represent பண்றதுக்கு தான் we will be using a term that is nothing but resistivity, okay. Resistivity வந்து ஒரு constant term தான், we will study. Also இது வந்து depending upon temperature. So now tell me guys what are the things? The resistance depends upon, okay, make a note because these notes will help you during the exam time, okay. You can just refresh and you can go. So in the resistance one the depend பண்றது length, okay, and area, also the material, the nature of the material, also the temperature. It is depending upon these many factors. Getting the idea? Now we are going to make a relation for resistance. We know resistance is proportional to L and it is inversely proportional to area. So in the case loda we are going to change the proportionality sign, okay. So now R is equal to rho L by A. R is equal to rho L by A. Understood? So now in the case la vanda resistivity adu vandu or constant da, okay. Resistivity vandu constant da. Again now ஒரு question கேட்க போறேன், you should think me and give a right answer. Length increases, okay, length increases, area also, I mean there will be a corresponding change will be happening with the area also. So what will happen to the resistivity? It is same as the what will happen? It will be same to the case we have mentioned in the Ohm's law. Resistivity வந்து it is not depending upon the dimension. Length increase பண்ணா என்ன, decrease பண்ணா என்ன, area increase decrease, it is not going to be affected at all, okay. Resistivity வந்து constant தான். இந்த மெட்டீரியலுக்கு வந்து this value is constant, okay. காப்பருக்கு வந்து ஒரு value, okay. அலுமினியத்துக்கு வந்து ஒரு value, அப்படிதான் the rho value is constant for each and every material. ஆனா அது வந்து டெம்பரேச்சரை டிபெண்ட் பண்ணிட்டு இருக்கு. ஸோ டெம்பரேச்சர் வந்து டெம்பரேச்சர் இன்க்ரீஸ் ஆகும்போது the rho value will also change. Understood? Everybody got it? Everybody got it? So now we got another relation for resistance, rho L by A. And unit vanda, in the resistance order, unit vanda, we will call it as ohm. Okay? Understood everybody? Understood everybody? Any confusion? Anything? Yes or no? Okay? So now we are going for the resistivity. Okay? Resistivity na, as I mentioned, adu one the constant for a particular material. It does not depend upon the dimension of the object. It depends only on the temperature. Understood? Understood? What is directly proportional? Which one? Which one you're asking? We will discuss temperature. Temperature ka we have to study a equation. Okay, we will discuss that. Don't worry. Okay, okay. So now resistivity vanda, it is a property of a material. Each material ku vanda different irukku, and it is not depending upon the dimensions of the wire or whatever we are taking. Understood? Got it? Now let us do a question. Are you guys ready? Ready? Ready now? Thumbs up. Okay? Excited now? Heart. Are you guys ready? Excited for the questions? Hey, nobody's ready, I guess. No quick responses. Yes, Damodaran, yes. I want more response. Yeah, some hearts is coming on the side. Yes, Sri Mardun. Okay, am I right or wrong? Rasita, yes. Yes, very good, very good. So let us do this question. A wire of resistance 160 ohm. Resistance 160 ohm is melted and drawn in a wire of 1/4 of its length. So initially the length A, and once after melting this we made into L by 4. The new resistance of the wire will be wire. Okay. So the new resistance of the wire. So in the type question vandena, you should think length increases na adoda proportion la area vanda decrease panna pore. So we can just go for the volume will be same. Okay. Melt anadukku before and after, and the volume vanda same. Appadina volume na area into length. So we can say A1 L1 which is equal to A2 L2. Okay? Adukapro, what is the unknown fact? We don't know what is A1 and A2. So now you can make a relation for A1 or A2 in terms of the known fact. Okay? Okay? Go for it now. Go for it everybody. You can do this question. First you have to equate the volume. We have to equate the volume. So in the first case, area A1, length L. Second case A2, I will be keep it as A2. Ana L2 L by 4. L cancel out. So we will be getting 4 times A1 equal to A2. Okay. Now I am going to write what is R1. In the beginning what was R1? Adha na ipo write panna poren. R1 na rho same material da. Okay, before and after melting, material is not going to change. Rho one the same. So we can just write rho L1 or L1 I will be just write L. Rho L by A. Okay. And inga I will be write it as A1. What is R2 guys? What is R2? Rho one the same. L1 the L by 4 A2. Now you can just replace A2. What is A2 now? Rho L divided by 4 into A1. Okay, 4A1. Now we know this value 160. Sorry, 160. R1 160. Now I'm going to rewrite R2. R2 na rho L by A1 into 1 by 4. Can I write it like this? Yes or no? Can I write it like this? Now R2 will be coming as in the value 160 ohm divided by 4. You guys got the answer? Yes or no? Yes or no? Tell me in the chat box, please. Tell me the answer in the chat box. Very good, very good, very good. Very good. Perfect. Okay, so this is how we will be doing it. You can just go for equating the volume. Adu mattunda we have done here. Okay, something new now in the question level. What we have done, we have just equated the volume. We didn't do anything new. We were just putting the values which is given in the question. Okay. Done. So now we are going for another one. Okay, conductance of a conductor. Okay, conductance of a conductor. Okay, so now conductance of a conductor, we will be represented as G. Conductance we have studied resistance, right? So resistance na enna? It is opposing the current flow. Okay, it is opposing the current flow. What you said? What happened here? What is the confusion happened? Any mistake I have done? Okay, so otherwise for this question you can again use, so again you can use one more equation. Okay, what is that equation? If you can do this R dash which is equal to n square R. N square na how many times it is decreased. That is the only thing. So you can just multiply with this. Okay, got it? Yes or no? Okay, so now on the conductance. Conductance na nothing but it is the inverse of resistance 1 by R. So upon the unit ohm inverse. Okay, conductance na G is equal to 1 by R and we will be getting ohm inverse. Okay, unit ohm inverse. Next one the conductivity. Conductivity na we used to represent it as sigma. Okay, sigma now what it is going to be? It is nothing but 1 by rho. Okay, so we are going to find the unit of rho. What is the unit of rho? We have studied R is equal to rho into L by A. So R into A by L the rho. Resistance na ohm, area the meter square divided by M which is equal to rho. Okay, so now we will be getting ohm meter, the unit of resistance, resistivity ohm meter. So now you can just go for the unit of sigma. What is going to be this unit of sigma? Ohm inverse meter inverse. Okay, so now we are going for the conductance. Okay, conductance and conductivity. Conductance we will be represented as G, which is nothing but 1 by R, the inverse reciprocal of resistance. Now, conductivity na the reciprocal of resistivity. And idoda unit vanda romba important. This is nothing but ohm inverse and inga vanda ohm inverse meter inverse the unit of our okay, the unit of this value. Okay, again confusion, huh? Okay, let us do this again. So the given factors, we can just start again. Okay, no more confusions, nothing. So we will be getting the resistance R1 which is equal to 160 ohm. Okay, listen here. Okay, listen here. Now we will be getting the new resistance R2. This is what our question. Okay. So the thing is like the volume will be same A1 L1 which is equal to A2 L2 and A1 L1 one the L, A2 L2 one the L by 4. Correct? Okay. The length becomes L by 4. So இப்போ வந்து 4A1 will be coming as A2. Till this any confusion? Till this any confusion? 10 the answer. Okay. You're not getting the answer? Yes. Is it 40? Sorry. Okay. Okay. 4A1 which is equal to A2. Now we will be going for R2 by R1. R2 na inna rho L2 divided by A2 divided by rho L1 by A1. Correct? So now we can just say rho L2 by A2 then A1 by rho L1. So idhula vanda rho cancel aichu. Adukaprom we will be having L2 that is nothing but L by 4 and we have A1 vanda we will be write it as A1, A2 vanda 4L. Okay, I'll be just add a multiple sign. Okay, and we will be having yeah, that's it. Okay, so this is what we have. Okay, so now we have marked L by 4, A1 and again confused. L1 on the L. Okay, so this is what we have. Now on the what will happen? What will happen? Sorry, I have marked A1. Sorry. Okay, so L1 the cancel aidiche, A1 வந்து cancel aidiche. So this one will be coming as 1 by 16. Okay, so R2 வந்து R1 into 1 by 16. So R1 vanda we have 160 into 1 by 16 will be giving you 10 ohm as the resistance. Okay, am I at the 40? I think I made some calculation. Okay, should we repeat this question again? Yes or no? Getting this question? If it is okay, we can move with the next one. Okay, wow. Okay, sorry. Should we repeat again? Yes or no? Fine. Okay, good. So now we were discussing about the conductivity and conductance and now we got the value. Okay, so next on it is usually asked multiple times. Okay, so we should find the vector form of, again repeat, oh my god. So R1 the 160 ohm, R1, okay, and if the same material is melted and it is making, so we can say the volume the same V1 1 equal to V2. Volume remains same. Now what is volume? A1 L1 which is equal to A2 L2. So in the first case, area வந்து A1, L1 வந்து L, area வந்து in the second case A2 and length வந்து change ஆச்சு, that is L by 4. இப்போ வந்து இந்த yellow cancel ஆயிடுச்சு. Now we have 4A1 which is equal to A2. Now we are going to write R2 by R1. R2 by R1 na rho L1 by A1 divided by rho L2 by A2. Till this it's fine. Okay. So now we will be going for rho L1 by A1, A2 by rho L2. So idhula vanda we will be cancelling rho because same material. L1 vanda L, A2 vanda 4A1, okay, divided by A1 into we will be getting rho L2 vanda again L by 4. So we will be getting n square vanda, okay. So again I made a mistake. Sorry. We should go for L2 term, right? Rho L2 by A2, rho L1 by A1. Nobody is saying I'm making mistakes, right? You should tell me now. Okay? So now rho get cancelled and we will be getting L2 by A2, A1 by L1. Correct? So now L2 one the L by 4, A1 I will be write it as A1, A2 one the 4 times A1 divided by L1 one the L. So L cancel ஆயிடுச்சு, A1 cancel ஆயிடுச்சு, 1 by 16 tha R2 by R1. Okay. So இப்போ வந்து we should know R2. So அதுக்காக we will be cross multiplying and R1 வந்து 160 divided by 16 will give you 10 ohm. Any confusions, anything, please let me know. If I need to repeat, I will repeat again. No worries on it. Fine now, just give me a thumbs up. No response. Okay, thank you. I hope there is a delay in the video as well as chat, I guess so. Okay, very good. So now we are going for the Ohm's law in vector. Okay, so idhula vantha we know that current vanthu vector illa, ana we have another quantity which is nothing but J is equal to I by A. Idhula we can just write I is equal to J into A. So in the question vanthu 2 marks derivation la most of the time they have asked. Okay, many times you can see that the same question has been repeated, the derivation, the vector form of Ohm's law, for 2 marks. Okay, so we will be writing like this. And we also know one more formula, I is equal to the V by R. Okay, and we have studied the potential and electric field relation. Okay, potential and electric field relation. So can you just give me potential in terms of electric field? Do you remember electrostatics? We have studied this. So tell me, what does V in terms of electric field? In terms of electric field. What is that? Electric field into EL, right? E is equal to V by L. So EL one the V. Perfect, Damodaran and synchronic. Sorry. Okay. So now we will be marked this. And what is resistance? R one equal to rho L by A. So I'll be substituting that as well. So L one cancel. We will be getting EA by rho. Okay, இது வந்து equation 2. So now current we have a relation there. We have a relation there, JA, and now we got another relation. Now you can see that the left hand side of both the equation is same. So I'm going to write 1 is equal to 2. So on the right hand side la enna irukku, J into A, and inga vandu E A rho. So idhila vandu we can just cancel A. What else we have? And the current density vandu equal to E divided by rho. So idu da vector form. Also we have studied in the 1 by rho na enna, 1 by reciprocal of resistivity na enna. What is the format? It is nothing but 1 by rho is equal to sigma. So we will be getting sigma E. J is equal to conductivity into this electric field. Understood everybody? So இது வந்து 2 marks காக கேட்டிருக்கேன். So you have to study this. Fine. So now let us go for the new one. Okay, the limitations of Ohm's law. Okay, limitations of Ohm's law. So limitations la vanta, the first thing you should understand is it is not a universal law. In the Ohm's law vanta universal law alla. Okay, universal law alla. Why? The reason that is what the limitations. It is not a universal. We know that when we say Ohm's law, first sentence itself, it is constant temperature. Okay, if the physical conditions remain same, correct? Okay, when we are saying Ohm's law, the statement of Ohm's law, and if you are not writing that terms, constant temperature or the physical conditions remain same, the answer is wrong, guys. That is not Ohm's law. Okay, whenever you are writing, because most of the students will lose mark in this because already we know it, but we won't write in a proper way. Ohm's law vanda at constant temperature or physical conditions remain same. This word you have to specify. Illana adu Ohm's law kedayadu. Ohm's law ku you will be getting 0 marks. Ohm's law vandu valid aagara condition da idu. In the condition specified pannalena you will be you are not going to get the score. So that is what we are saying. This is not a universal law. Temperature change pannina, Ohm's law vanda, it's not going to be the same. Okay, so temperature increase agumbodhu in the limitation of Ohm's law started. And idu vanda obey pandra, we know that few the metals, conductors vanda idu obey pandra. Adinala, we can say that the semiconductors and also the PN junction diodes, these are all not obeying Ohm's law. Okay. So it is not obeying the semiconductors and everything is not obeying Ohm's law. Adinala we will be call it as non-ohmic. Okay, ohmic and non-ohmic conductors are there. Which are the conductors which is obeying Ohm's law? That is what? Ohmic conductors, and another one is which is not obeying. So on the segregation irukku. So idu vanda specific ana konjam, it is applied only for some particular things. And the we have that V by I graph. That slope must be linear. Ana temperature increase pannumbodhu at higher temperature Ohm's law is not valid. Okay, other is not going to be, it is not going to be linear. It will not a linear graph. So adinala high temperature la vanda Ohm's law valid kedayadu. Okay, very it is easy. So at some point this is what I, so we can say that till this will be constant. Adukapro it should go like this, ana vanda it will change. Okay, so this is what the major drawback or limitation of Ohm's law. It is not a universal law, and of course at high temperature this law is not valid, and it is only valid for the ohmic conductors. Okay, so that is what the limitation. Next one, the thermal velocity of electrons. So let us say எனக்கு வந்து இப்போ ஒரு copper oda wire இருக்கு. Okay, let's imagine this is a copper wire. So idhula vandu இந்த electrons move பண்றதா இல்லையா? Because it is a metal, right? அதுல வந்து free electrons இருக்கு. அந்த free electrons rest ஆ இல்ல it is moving? Tell me, rest or move? Yes, of course. And also, whenever you're writing any of the questions, okay, whenever you're writing any of the questions, make sure maximum points, maximum diagrams, everything is there. Because even if you have missed 1 or 2 points also, the teachers will feel like, yeah, the student knows something. Okay, the student is good in it. Okay, so we will be giving the mark. So, adinalada, eppovume don't be like, okay, I will write this only. No, don't do that. Okay, whatever you know about that topic, please try to write it. Okay, so appadina you will be getting extra marks. Okay, you can balance. So, adinala you should draw the diagram as well. So, now on the thermal velocity, yes, Damodaran, it is correct. Thermal velocity, we are just going to start. As I said, so if we are not even applying any potential difference electric field, then also the free electrons in this wire will move. Okay, so let us say this is the conductor what we have. Idhila vanda there are many free electrons. Conductor la vanda many free electrons. In the electrons vanda it will go for a random motion. All this will go for a random motion. Okay, so that, I mean, all we can just say that whenever we have a electron, that electron will move like this, then it will collide with someone, and then it will move like this, again it will come. So like this way it will move around. It is going to be a random motion. And due to this random motion, this I mean the velocity acquired due to this random motion in the absence of electric field, we will call it as thermal velocity of electron. Okay, organic vandu enakku theriyada, ma'am definitely will take. Okay, so what is thermal velocity? The velocity attained due to the random motion of charges in the absence of electric field is known as thermal velocity of electrons. Purinjada? In the statement important da, because after this we are going to study another velocity. So thermal velocity na enna? The velocity attained due to the random motion of electrons, and in the absence of, this is very important, in the absence of electric field vandu known as thermal velocity of electron. Ana vandu you just imagine I am the one electron. Okay, I will go here and I will just hit with some other electron or ions. Again I will move here, again I will hit with someone, again I will come back. So in the random, due to this random motion, in the electron will come and I mean it will just go like this, again it will come back to the same point. Appo on the displacement na enna? And the case la displacement enna? Tell me. In the case la displacement enna? I didn't get any update yet. Okay, definitely if it is released, we will update. Okay, no worries. Let's focus in the class right now. Okay, so displacement on the 0. Very good. Okay, displacement on the. Okay, I don't know. Anyway, I'm focusing on the class. Just forget about the rest of the things. Just stay. Okay, and in the 5 minutes we can just go for the lunch break. Okay, so now we know that it is exhibiting a random motion. Random motion na, it will go here, come back to its original. Okay, so displacement on the 0. In the thermal velocity of an individual electron on the 10 to the power 6 meter per second and the range la irukku. Okay, individual electron oda velocity vandu thermal velocity of electron vandu 10 to the power 6 la irukku. Ana the problem enga irukku? When it is going like this, it becomes 0. If you are just considering the average, the total velocity of the conductors in that, it is coming as 0. Yena, okay, it is not going to move forward, it will come back. Adinalatha, we are just mentioning it as random motion. Of course, one we have done, we will do the rest also. Don't worry, just stay on the life. Okay. So now, thermal velocity, na, as I mentioned, adoda magnitude, individual electron oda magnitude vanda high da, ana vanda total paakumbodhu it will be coming as 0. Okay. Next one vanda thermal velocity ku appuram drift velocity. Again, I'm reminding you what is the thermal velocity. Thermal velocity na enna? In the absence of electric field. Okay. In the absence of electric field. Focus pandiko. In the word vandu romba important. In the absence of electric field, what is the velocity of the particle? Ana vandu drift velocity. Okay, drift velocity na in the presence of electric field. Okay, so I'm going to write here the velocity attained by the charges in the presence of electric field. So in the presence of electric field na advantage enna? So idu da vandu nama conductor. Okay, idula vandu electrons irukku. So ana in the electrons vandu random motion da, but it will move forward only, it will never come back. I hope you are getting the idea. Whenever we are applying the electric field, in the electrons it will just move like this only, but it will move in the single direction. Okay, it will move in the single direction. Adinala velocity 0 agadu. On a previous case it will go like this, again it will come back and it will come to the same position. Adinala the total velocity 0 agadu. Ana when we are applying the electric field, in the electrons konjam random da, analum it will move in the forward direction. Okay, it's not going to be a straight line. Ana it will move in the same positive direction. Purinjada? So that is the major difference between drift velocity and the thermal velocity. And idoda range was the 10 to the power minus 3 meter per second, 10 to the power minus 4 meter per second. Adada in the drift velocity range. So in the two velocities, you got the idea about these two velocities? Yes or no? Yes or no? So velocity attained by the charges in the presence of electric field is known as the drift velocity. Adoda order vanda 10 to the power minus 3 meter per second. Next vanda in the drift velocity oda, what is it? We should know the representation, mathematical representation. Adhikku vanda we can just use the equations of motion. V is equal to U plus Et. U vanda 0. Okay, initially whenever we are applying the electric field, and the moment the beginning stage velocity 0. Next acceleration. Acceleration na enna? F is equal to ma. Correct. F na enna? We know QE. Last chapter we have studied this. Force is equal to charge into electric field. So, we can just write QE by M, which is equal to A. Now, I am going to substitute here. What is that? Q na enna? In the case of the electron, I am replacing it EE by M into T. Now, let me talk about this T. So, in the case of T vanda, just give me one more second. We can just finish drift velocity. Then we can go for the lunch break. Okay. So we know V is equal to EE by M into T. So in the T na we will be call it as relaxation time. Relaxation time enna the time between inga or electron irukku. Okay. Anga or electron, ion, whatever it may be distant. So in the electron vanda it will travel some distance and it will hit on a particle. Okay, it will hit on a particle. So that time between two successive collision. Time between two successive collision is known as the relaxation time. So we can write the drift velocity as EE by M into tau. We will be represented as tau. Okay. Next one, we have to study one more term, that is nothing but mean free path. Mean free path na enna? Mean free path na very simple. As I mentioned, now the electron is here. It is traveling some distance, and the distance in the mean free path. Okay. So you should know the terms as well. So these are the things we have studied till now. Next one, the mobility. Mobility na another term. Okay. Some fantasy names da. வந்து அவ்வளோ difficult ஆன இது இல்ல, ஆனா multiple times கேட்டுட்டு. So mobility now we will represent it as mu. அது வந்து equal to the magnitude of drift velocity divided by electric field. Okay, mu is equal to Vd by electric field. So we can just define mobility, the drift velocity, the ratio of drift velocity, magnitude of drift velocity to the electric field is known as mobility. So in the mobility we should know what is the unit of mobility. So இப்போ நீங்க பார்த்தேனா Vd drift velocity எந்த type of velocity ஆனாலும் what is the unit, அது வந்து meter per second. And electric field வந்து Newton per coulomb. Okay, so we can just say the unit வந்து m coulomb second inverse Newton inverse. Illena we can also go for meter per second the velocity unit. Electric field we have already studied another one, volt per meter. So அப்படினா meter square S inverse V inverse will be the another unit. So in the unit வந்து ரொம்ப important, you should study. Okay, understood? So next month we should study the current in terms of drift velocity. So we are going for the lunch break. So ipo vandu 1:50. Okay, so we will be back at evlo time veno. So ipo vandu 1:50. So we can just go for 1:50. So you have to take a proper break, have your lunch, and we can just continue with the rest of the part. Then we will be also solving a lot of questions. That is very important. So 1:50 PM everyone should be here. Okay, see you. Hello everybody. Am I audible, visible? Hello, hello, hello. Are you guys there? So if you're there, just give me a thumbs up, and if you are ready, give me a heart, please. So let us just continue the session. Everybody, how are you? How was the lunch? So, ஆரம்பிக்கலாமா? Everybody is ready. So friends, okay, share paniko. Also those who are coming late, you should watch the first part as well as you should like, okay? Also subscribe the channel. And I wanted to tell you one thing. We are releasing PYQ 38 years PYQ book. So everyone have to go through it, and the link, everything is pasted in the description box itself, so you can just check out, and you can, I mean, if you feel like, yeah, that's good, that's a good one, you can just go for it. Okay, so yes, Joshua is ready, Damodara is ready, yes, let's go for it. So now we are going for the current in terms of drift velocity. Okay, so we are going for the next today it is not possible. I will do 10 minutes video of that chapter, just a quick revision, and the chapter we will be discussing in the next Sunday session. Okay, we won't leave any of the chapter. We will cover all the chapters in Sunday and Monday. You don't have to worry about anything. As I mentioned, I will do quick revision videos as well in this week itself. Okay, fine. So now we are going for current in terms of drift velocity. So we know, I'll start with current. What is the equation for current? What is the equation for current? Can I say Q by T? Can I say I is equal to Q by T? Q na we already studied. N E by T. Right, N E by T. So first step is, first, of course, Joshua, you didn't even came for this session, right? Now only you're coming. You're not on time. You should come. Okay? So Q is equal to N E by T. So now I'm going to introduce one term. Okay? I'm going to introduce one term that is nothing but N. It is not as same as the NE we are writing. This one the total number of charges per unit time. Okay, total number of charges per unit time. Okay, total number of, wait, everything won't go. Sorry. Okay, so this is nothing but the total number of particles in unit volume. Okay, total number of particles in unit volume. Okay, so listen here. We are going to study current in terms of drift velocity. This is very important. I mean, this also is an important derivation. As I mentioned, 2 mark, 3 mark, it used to ask. So I is equal to Q by T, and next one the N. N is nothing but N by V. The number of particles divided by volume. Okay. Now, if I'm doing N into AL, I will be getting the total number of charges. Okay, N into volume. Okay, per unit volume, the unit volume ivlo irukku, appo vandu total ah irukka poradhu ivlo da. So now I'm going to write here N na enna, N A L. Okay, charge na Q is equal to N E, so I will be mention it as E. Okay, divided by the total charge divided by time. So இப்போ we have a conductor. The conductor order length L, and definitely the area A, and the total number of charges N A L E. Okay. So now I'm just thinking. Okay, this is the conductor we have. Imagine this is the conductor we have, and as I mentioned, இந்த length வந்து L. இப்போ வந்து இந்த charge, இங்க இருக்கிற ஒரு charge, it is traveling towards here. The total distance traveled is nothing but L. Correct? Okay. The total distance traveled by the charge is nothing but L. And அதை எடுத்த time வந்து T. So, the total displacement divided by time வந்து nothing but the velocity. Okay. So now here I will write NAE into L by T. Ana L by T வந்து drift velocity. Okay. இது வந்து drift velocity. Now I got I is equal to NEAVD. இப்போ வந்து I got the expression for current. Okay. I got the expression for current. Now I know J na enna current density na enna I by A. So இப்போ வந்து we know what is I. NEAVD divided by A. Okay. Got it? So now in the A will be get cancelled and we will be getting NEVD as the current density. So now we got another equation, another important equation. Adu vandu NAVD. It is nothing but the current density. All good? Okay? Okay. So now we are going for one question. Drift speed of electrons. Okay, drift speed of electrons when a current 1.5 ampere of current flows in a copper wire of cross section. Area is given as 5 millimeter square is V. The drift velocity is given as V. If the electron density in copper is, okay, electron density na the small n na the total number of particles or electrons divided by the volume. Okay, other one that is given as 9 into 10 to the power 28 per meter cube. 1 unit volume 9 into 10 to the power 28. Avlo charges irukku. Now you should find the value of V in millimeter per second, and you can just go for a close to value. So nth equation we can use. Which equation we can use for this question? We have I, we have A, we have N, we have E, and we need to find the drift velocity. So we can just go for the equation I is equal to NEAVD. Correct? So ipo vandu we can just go for I divided by NEA, which is equal to VD. Can you do the question? Can you give me the answer in the chat box? Let me see who is going to give the answer first. Yaar, first answer podo. Let's see. Do the calculation. So ipo vandu current vandu 1.5 ampere divided by N vandu 9 into 10 to the power 28, E vandu 1.6 into 10 to the power minus 19 into area vandu 5 millimeter square la. So we have to convert 5 into 10 to the power minus 6 meters. So go for it now. Approximate value that we need. So you can just cancel 1.5, 1.6 because approximate close to value that we need it. So you don't need to do the perfect calculation. This will be get cancelled. Adikapra we have 9 and 5. 9 into 5 on the 45. And in the powers calculate pannumbodhu what we will be getting 19. That will be 25. 10 to the power 3 will be coming in the denominator. So ipo vanta we will be getting 1 by 45 into 10 to the power minus 3 meter per second. And we need the answer in millimeter per second. 1 by 45 now almost it will be coming around 0.02. Yes, very good. We need in millimeter per second. We need in millimeter per second, guys. Very good, Joshua. Very good, third party. Okay. Yes. So, as I mentioned, 1 by 45 now, almost 0.02. So, you will be getting 0.02 into 10 to the power minus 3 meter per second. So, we can just write 0.02 millimeter per second. Purinjida, anybody is having confusion, please? Yeah, 1 by 48, it is correct. As I mentioned, we are approximating it. Okay, that is why I have done. I have just cancelled 1.5 and 1.6, and then I have done 9 and 5, that is coming as 45, and then we have just calculated the powers of the 10. Okay, Purinjada, all good, all set. Let's go for the next one. Next one, in the resistivity order relationship with the relaxation time. Eppadi start pandrathu? How we will be starting? We need the relationship between resistivity and relaxation time. Sorry. Okay, let's go for it. We have I is equal to NA VD. Now I'm going to write what is VD. NEA. What was VD? EE by M tau. Right. This is what we have. Okay. So this is what we have studied. So I'm just writing N E square A E tau by M. Now in the left hand side we have I. Now I'm taking this area over here. So I by A vanda we will be getting the current density. In the current density we can just write it as N E square tau by M into E. Getting it or what? Those who are coming, don't forget to like, also share with your friends. We need to study and we need to crack it. Okay. In the chapter finish pannumbodhu, you will say current electricity. Enna questions varatum, we will be getting the 9-10 marks for sure. Okay. Anta alavukku we have to prepare and we should make sure our friends are also studying this. Okay. So we got this. Now Anta, we know the vector form. J is equal to sigma E. Now I'm comparing this one. What is the equation? J is equal to N E square tau by M into E. Correcta? So now I'm just comparing these two equations. Left hand side one the same. And in the right hand side, if you're just checking, E is there. Okay. Appa vanda I can write sigma is equal to N E square tau by M. Sigma na enna reciprocal of resistivity. So adu vandu N E square tau by M. So resistivity vandu M divided by N E square tau. Okay, idu vandu previous years la kettitu irukku. So you have to study the you have to study how to derive this. Very simple. We are not doing anything new. Current order equation we have already derived it. Okay, we will be writing the current equation. Vedike substitution pandra. Adukapro we will be comparing J sigma E versus this equation. After that we will be getting sigma. Everybody got it? Yes or no? Yes, na, give me a thumbs up. Thank you, Damodaran. You're very active in the class. Very good. Okay. Others, please respond. If it's okay now, we can go for the next. Okay, very good, thank you. So now we are just going for the temperature dependence of resistivity in material. Resistivity, how resistivity varies with the temperature. Okay, so in the case metal order, we know we have studied resistivity. Resistivity equation anna M divided by N E square tau. Idha we have studied this equation. Am I right or wrong? Yes or no? Yes or no? Okay. So, whatever I'm saying, it is very important. In the question you have to write it like this. Okay. So, you need to write the temperature dependence. So first la vandu you will be drawing the graph. Adukapra you will be writing rho. Okay, rho na enna resistivity. Resistivity na enna m by n e square 2. Okay, so in the case la vandu temperature increase ஆகும்போது இல்ல decrease ஆகும்போது how it is changes in the resistivity changes. So நீங்க மெட்டலோட இந்த electron concentration வந்து constant, m வந்து constant, e square வந்து constant. அப்போ we can say that rho is proportional to 1 by tau. Tau na enna relaxation time. இது வந்து ரொம்ப important. Okay, relaxation time. So in the equation la we understood rho is proportional to 1 by relaxation time. Okay, so ipo vanda temperature increase pannina, okay, temperature vanda raise aiduchu appadina இந்த electronக்கு extra energy கிடைச்சிருக்கு. Okay, extra energy கிடைச்சிருக்கு. Okay, so let us say you are not even had anything for few days. How you will be lying down somewhere, correct? Ana appo vandu you got a biryani, you will have it and you will become more energetic, right? So in the temperature increase பண்ணும்போது what will have this electrons in the kinetic energy ரொம்ப அதிகமா கிடைக்கும். அந்த energy கிடைச்சிட்டேனா, so let us say whenever as I mentioned, we didn't had anything, so on the time la vandu we will walk like this. Ana we got the biryani, what will do? We will run, right? So exactly the similar way temperature increase ஆகும்போது the collision ரொம்ப fast ஆ நடக்கும். Okay, இதுக்கு energy extra கிடைச்சிருக்கு, so it will just go like this. Okay, so temperature increase பண்ணும்போது relaxation time வந்து it will reduce. Okay, the relaxation time வந்து reduce ஆக போகுது. Okay, so in the relaxation time reduce பண்ணனா what will happen here? This will increase. ஏனா அதோட inverse relation தான். Okay, புரிஞ்சுதா? When temperature increases, the electrons will get an extra energy. The collision time, the successive collision time between, it will decrease. So relaxation time decreases. Now, in the relation, if you are just checking with this relation, we will get to know the resistivity increases. Okay, so idoda answer. In the rest of the three terms, one the constant for a metal or a conductor. So idha one the relation. T increases, tau decreases. So sorry, idu one the increases. So resistivity one the increase. Okay, resistance also increases. Okay, in the resistance resistivity one the same relation. Instead of that, if you are writing R also same, because R and rho is both like the concept is same. Okay, so this is the first segment we are going to study. Now in the same question we can expect for the semiconductors as well. So first one we will be drawing the graph for the semiconductors. In the case we will be going for resistivity is equal to m divided by n e square 2. So in the case we know in the semiconductor in the charge carriers amount romba less. Okay, so adanala in the relaxation time there is no much importance, there is no significance in the relaxation time, because when we are comparing with the conductors, the number of charge carriers is very less in semiconductors. So on the time in the relaxation time relevance illa. So ipo vandu nokina n e square tau will be constant, and we can say that the resistance will be connected with n. Okay, this will be proportional to 1 by n. Ana when temperature increases, semiconductor chapter we have learned, when temperature increases in the number of charge carriers enagum, when temperature increases in the n value the increase. Purinjada everybody? So when temperature increases in the semiconductors the n value, the number of charge carriers increase aga pore. So appadina n increases it is an inverse relation. So resistivity on the left side. Okay, so in the semiconductors la vanda m divided by n e square tau. Okay, so ipa vanda m e square tau in the three quantities vanda constant aga pora in the case of semiconductor. So appadina in the resistivity is completely proportional to 1 by n. அப்படினா temperature increase பண்ணும்போது n value increase ஆயிடும். n value increase ஆயினா since it is an inverse relation rho value வந்து கம்மி ஆயிடும். Got it? Understood? Everybody? So இப்போ வந்து we have to study one more equation. R is equal to R naught into 1 plus alpha delta t. Using this equation, we have multiple questions. Okay, so R vanda konjam time ku appuram what is the change which is happening in the resistance? Okay, so idhula vanda alpha vanda coefficient of thermal conductivity. So idhula vanda alpha value positive for the metals, negative for semiconductors. And negative also, it is very, very small. We can also say it is approximately 0 for insulators. Got it? So in the relation, you have to by heart R which is equal to R naught plus R naught into 1 plus alpha delta T. Okay? Semiconductor வந்து ரொம்ப simple. Semiconductorல number of charge carriers வந்து கம்மி தான். Okay, ஆனா temperature increase பண்ணும்போது இந்த number of charge carriers வந்து increase ஆகும். Okay, இந்த number of charge carriers increase ஆனா what will happen? The relation வந்து rho is proportional to 1 by n. So inverse relation so n increases, rho decreases. அவ்வளவுதான். ஆனா வந்து conductorsல tau will be decreases. அதுவும் inverse relation தான். Tau decreases na rho increases. அவ்வளவுதான். Very simple. Okay. Okay, so now we have another relation as I mentioned, R naught into 1 plus alpha delta T. Okay, so those who are coming new, you should like the video as well as you should subscribe the channel because lots of amazing sessions are waiting for you. I'm telling you, we will finish and we will get good score. So trust me guys, we are going into it. Okay. And in the current electricity வந்து ரொம்ப important ஆன chapter. எங்க பார்த்தாலும் question தான். You can't skip anything. Okay. இந்த yearல இந்த concept கேட்டுட்டேனா next yearல வந்து next one. So we can't just stick with okay this topic we can't. Okay. Almost all topics are relevant. Okay. We will cover everything. So now வந்து we are going for the question. Okay, let us do the question. Are you guys ready? Ready na? Thumbs up to go. Ready now? Thumbs up to go. Ready now? Thumbs up to go. Excited na? Heart. Okay. In the side la heart irukku. Okay. So, ipo vanda we have two wires. Okay, we have two wires. In the two wires X and Y. Same material da. Same material. Okay, I will read bestie. Hi bestie. Okay, I will read. We have two wires X and Y. Same material now, what we can assume? Okay, same material now, what we can assume? Rho one the same. Okay, rho one the same. Equal length. This will be same length. Having area of cross section A and 2A are connected in parallel. Okay, so in the two wires parallelly connected. Okay, it is connected parallelly. This is X and this is Y. Okay, so now across an ideal battery. Okay, so we have connected with an ideal battery of EMF E. What is the ratio of current density? Okay, simple question tha. We have two wires X and Y. Okay, it is connected parallel with a battery which is having an EMF E. Okay, same material, same length, and area வந்து A and 2A. இப்போ வந்து what we need to find the ratio of the ratio of the current density. Can you find it, guys? Can you find it? Can you find it? Current density. In the data which we have to find it. In the data mattunda irukku. Two wires X and Y connected parallel to a battery which is having EMF E and same material, same length, and the area one the different. How to start? How to start? How we can start? So இப்போ வந்து நீங்க பார்த்தேனா we know this one is nothing but IX by AX divided by IY by AY. ஆனா I na என்ன? I na என்ன? I na என்ன? I na nothing but current. Okay. We can just write it as V by R. Correct. We can write V by R. And inga vanthu we will be having the area of. Okay, got it everybody? Ana, I'll just read it separately. Okay, so ipo vanthu I na V by R and we have A and R vanthu we can just write it as V by rho L by A divided by A. So now A vanthu cancel aidum. Okay, so what we have after that? We will be having V by rho L. Okay, we will be getting V by rho L as the what? The current density. Okay, can you just give me a minute? I'll just come in a minute. Okay, just give me a minute. Okay, you can just try this question. You can just work out with this one. Sorry guys, sorry. Let's just continue. Okay. Fine, audio, video, everything is perfect. Let's continue this. Okay. So now we will be going for J is equal to V by rho L. We got V by rho L. So now we can just see that since they have connected parallelly, okay, they have connected parallelly. So what will happen, guys? Which quantity is going to be same? If it is parallel, which quantity is going to be same? Which quantity is going to be same? V. So, we can just write Jx by Jy will be coming as what we have. V, that will be same. Rho will be same. L will also going to be same because it is mentioned rho, L, and V also, potential also same because it is connected parallelly. So we will be getting V by rho L. So we will be getting 1 by 1. So the ratio on the 1:1. Understood everybody. So இன்னைக்கு வந்து we have discussed the ratio of two wires which is having a current density, which one is having a made up of same materials, same length, ஆனா area வந்து different இருக்கு. So we were just trying to write the equation in terms of the given data. So we will be getting the answer as 1:1. Okay. So yes, Damodaran, 1:1 is the answer. Bestie, yes, that is the right answer. 1:1. So we are going for the next question. We need to define drift velocity. Okay, I'll read the question, then you will understand. Okay, we need to define drift velocity of electrons in a conductor connected across a battery. What is drift velocity? The velocity attained by the charges, or let's say free electrons, when in the presence of electric field. Okay, figure shows variation of drift velocity. I think you can see the figure. In the y-axis la vandu Vd and in the x-axis la vandu V. Okay, we have copper wire A and B of different length. Okay, length vandu different irukku. The potential difference applied across the electrons in two copper wires A and B of different length versus the potential difference applied across their ends. What does the slope of this line represent? Which means the slope na enna Vd by V. The drift velocity by potential difference. Adu enna? Eppadi connect pandrathu? Vd by V. So we can just write Vd na, we already know E by M tau divided by potential, we can just write it as EL. Can we write it like this? Yes or no? So ipo vanda we will be get to know E will be get cancelled and this one will be coming as E tau by ML. Okay, Vd vanda E by M tau divided by EL. E will be cancelled and we will be getting E tau by MN. Okay, otherwise we can also say the Vd by V. Vd na in terms of mobility. Okay, mobility we can write mu into E divided by potential na E into L. So we can just cancel E. We will be getting mu by L. So the slope of the graph, either we can say mu by L or let's say E tau by ML. Okay, so those who are coming to the session, don't forget to like. Also subscribe the channel. All the chapters, everything we will finish in few days. So next one, which wire is too long? Okay, the question it is asked which one is long. Okay, A or B. So we understood this is the slope on the mu by L. So now you can tell me which one is going to be having length more. Very good. Try it. Very good. Others, please respond. So in the case la vanta slope kammiya irukkiradhu vandu 4B. Ana in the slope na mu by L. Okay, slope vandu mu by L. So slope less for B, அது inverse relation la irukku. So we can see that the slope mu by L vandu constant. Mu by L vandu constant. In the graph பார்க்கும்போது we can say that mu by L vandu constant. And idhila vandu the slope is less for B and the slope inverse da. Right? Inga பார்க்கும்போது we can say that it is actually proportional to 1 by L. So now you can say that here in this case, slope is less for B. So the length will be more for okay. So in the question la very simple on a question. We know VD and V is plotted in the Y and X axis correspondingly. And now we should find what is VD by V. Drift velocity divided by potential. Adukkaga we should find the equations of the corresponding thing, and we will be getting this. Okay, and in the graph the straight line, so it is constant, slope on the constant, so I can write mu by L the constant. So in the mu by L value it is very less for B, so we can say L which value should be, this value should be less. Okay, அப்படினா L பெருசா இருக்கணும். So in the case L max. புரிஞ்சுதா? Yes or no? Yes or no? So now we are going for another question. Define the term mobility. Mobility na enna? It is nothing but the ratio of drift velocity, magnitude of drift velocity to the electric field. Obtain the relation for mobility in terms of relaxation time. We know mobility which is equal to VD by E. VD EE by M tau, okay, divided by E. So we will be getting E by M tau as the mobility in terms of relaxation time. Got it, everybody? Yes or no? Yes or no? So now we are going for the next question. Define the term drift velocity. Again, I think this is the same question. No. And obtain the relationship between current density and drift velocity of electrons, that we have already done. Okay, current density, drift velocity, that same derivation, J is equal to NEVD. Okay, so according to the weightage, you should start with finding from current. Okay, so you can just start with I is equal to Q by T, Q na N into A into L into E divided by T. So this will be coming as NAVDE. Adukapro we will be taking A and we will be finding this. So next one, the meter square, V raised to -1, S raised to -1. Meter square, V inverse S1. So this belongs to which quantity it is? Drift velocity or resistivity or drift velocity, resistivity, mobility, potential gradient. So which unit it represents in the quantity? Very good, very good. It is mobility because we already derived it, right? Mobility the VD by E. VD na meter per second, E na volt per meter. So ಇದು the meter square, S inverse, V inverse. So we can say the answer the mobility. Next, differentiate between random velocity and drift velocity of electron in an electrical conductor. Give their order of magnitudes. So in the question lab, we have to write what is this random velocity. Random velocity na in the absence of electric field. Okay, in the absence of electric field, the electrons it will be making random motion and it will be the average value yes, very good, very good. The average value 0. Okay, ana individual particle ku 10 to the power 6 avlo velocity irukku, ana adu useful alla, like it is not going to make any current. So you can also say in the random velocity, due to this random velocity, it is not producing any current. Okay, you can add that as well. Due to the random velocity, we are not getting any benefit, or let's say we are not getting any current. Ana drift velocity we are getting the current. Also, we can define that it is nothing but the current, the velocity in the presence of electric field. And then the range 10 to the power -3 meter per second. Next one, the conductor of uniform cross-sectional area is connected across a DC source of variable voltage. Draw a graph showing variation of drift velocity of electrode as a function of current density. How we will be doing this? Just imagine we are going to plot the drift velocity versus current density. So first we should know the relation connecting. What is the relation? NEVD. Correct? NEVD. So if I want the NE, want the constant for a conductor. Appadina J is proportional to VD. So it will be coming as JVD will be coming as a constant. I mean, it is a straight line with the slope. What is going to be the slope? J by VD will be coming as NE. Okay, show the graph between, here we should go for, okay, this is fine. In the question, we should go for what? VD versus J. Okay, VD versus J. Okay, same graph only. And the slope one the 1 by NE. Sorry. Got it? Understood? Okay, so this is again very simple question. How does the mobility of electrons in a conductor changes if the potential difference applied across a conductor is doubled, keeping the length same, temperature same? Okay, length, temperature constant. If V becomes 2V, how mobility will change? What is going to be the new mobility, the mu dash? Tell me how we can do it. This is the concept. Temperature, length is constant. Potential we are making into double. What is going to be the change which is happening to the mobility? Naleki vanta physics ella, I think chemistry or biology. Tuesday vanta physics. We will be covering ray optics, I guess. Ray optics and wave optics. 2 chapters in 4 hours. We will discuss the PYQs also. Think again, what will happen to mu? So now we can just go for the relation mu, which is equal to VD by E. Correct or wrong? Okay. So now length is same, temperature is same. So it is not going to, the drift velocity is not going to change. Okay, drift velocity will remain same. So now we will be having E as E, I can just write it as V by L. Can I write it like this? Because we know V is equal to EL, or let's say E is equal to V by L. Okay, so now I can just say that this mu is proportional to 1 by V. Now, if we make V to 2V, what will happen to mu? It will become mu by 2. It will become half. Purinjida, any confusion, anything, those who are coming, don't forget to like. Okay, we need more likes. At the end of the session, we need 200 likes. Okay. Yes or no? You will make it 200 or what? Or you will become confused. You won't give any likes, no subscription. We will just watch the videos and we will go. We won't even talk. Okay. So now this is what I said. Vedantu is providing Neet 38 years book. So if you want it, if you feel like it will be very helpful, you can do it, because PYQ practice vanda romba important. Okay. In the journey la vanda, it is very important. So we are going to the next segment. We did few questions. Okay. And as I mentioned, current electricity la vanda, we cannot avoid a single topic. Ella topic and the topic one the question tha. Okay, sometimes we will say from this topic we can expect numericals. It is not about just numericals and the concept a question. Okay, so next one we are going for electromotive force, terminal voltage as well as internal resistance. Okay, are you guys ready? Yes or no? Yes or no? Arambikalama? As I mentioned, don't ask the hours. We will study. That is the only motive. Okay, we are not going to think about the time. Okay, now heart. I want more hearts. I want more likes. Okay, so now we are going for the next segment of this chapter. So on the what is a cell? What is a cell? a cell we can define a device which convert chemical energy into electrical energy. Chemical energy, it will convert chemical energy into electrical energy. Okay, next one the EMF, electromotive force. Even if we say electromotive force, that force illa, adu vandu work done. Okay, adu vandu work done. It is defined as the when, I mean, if we have a cell only, okay, we have a cell only, we didn't connect anything. Let us say this is an open circuit. Okay, it is a open circuit. No current is flowing. If there is no current flowing, it's making lots of kinds here. Okay, if no current flowing in the circuit, which means it is a open circuit. அந்த டைம்ல இருக்கிற voltage தான், அந்த டைம்ல இருக்கிற voltage or potential difference தான் இந்த EMF. Okay, EMF வந்து open circuitல இருக்கிற potential difference. ஆனா we have terminal voltage. Terminal voltage என்னன்னா, it is again very simple. When there is a current flowing through it, okay, when there is a current flowing through a circuit, if more specifically I can say, இது வந்து closed circuit. Okay, in the closed circuit na, we can say that அந்த டைம்ல இருக்கிற potential difference வந்து terminal voltage, terminal potential difference. இப்போ வந்து we are going for the internal resistance. Okay, internal resistance வந்து very very important. Internal resistance. So, as I said, usually what we will say, we will be having a battery like this. Okay, positive and negative. Okay, what is inside? Okay, what is inside? You will be studying a lot in chemistry part. Now for physics, let us say we are making, or let's say we have two electrodes. Okay, we have two electrodes. We will dip this in a electrolyte. This is the solution. Okay, idla vanda ions kuda mobile da. Ions, I mean, ions will flow. So, இப்ப வந்து cell na adula electrolyte irukum. Okay, adula வந்து electrodes irukum, positive and negative, anode and cathode, everything is there, but we don't need it. Okay, so in the time in the charges வந்து what will happen, it will flow through the electrodes, then it will come to the electrolyte, again to the electrodes, ippadi it will just go like this. So again before coming outside, okay, now we are not even talking about something happening outside. I'm still stuck with whatever be the things which is happening inside the cell. In the cell kulla, what is happening? The charges is flowing like this. At the time flow of charges na enna, it will be producing some current. Okay, at the time current na resistance, right? Resistance iruko. At the time in the electrolytes provide panta resistance, the internal resistance. Let me repeat again. If this, we have a cell, and inside the cell we have electrodes and electrolyte, and what will happen when the charge is flowing through the circuit? The electrolytes will provide a resistance, and the resistance mattunda, not outside. We are not talking anything about outside. Inside in the cell kulla, in the electrolyte provide panta resistance, the internal resistance. Okay, understood? Everybody understood? So now ipo the internal resistance discuss panniyachu, EMF and terminal voltage. Okay, and in the internal resistance depends upon few factors. First one in the electrodes, the nature of the electrodes, also one the electrolyte, okay, and the distance of separation between the electrodes. Okay, in the distance adhigamana enna agum? Yes, this charges has to flow longer distance. Again, longer distance now what will happen? Longer distance na enna agum? Again resistance will increase. So electrodes oda nature, electrolyte oda nature, distance between the two electrodes, and area of the electrode, which means how much it is dipped in the electrolyte. So idella vanda romba important ah irukku. Also vanda temperature of the electrolyte. Okay, temperature of the electrolyte. So it is depending upon all the factors. Okay, so nature of electrodes, nature of electrolyte, as well as the distance of separation between the two electrodes, temperature of electrolyte, also the area which is inside the electrolyte, it is also depending upon that. And you guys, I hope you guys understood, because இது வந்து ரொம்ப important ஆன concept. ஏனா whatever we are studying from now, okay, whatever we are studying from now, that is the key for the rest of the concept. புரிஞ்சிடுச்சுனா just give me a thumbs up. Okay, these topics are வந்து ரொம்ப important ஆ இருக்கு. அதனால தான் again and again I'm repeating. So நம்ம EMF வந்து the potential difference da. EMF na potential difference da when the circuit is open. Terminal voltage na அதோட potential difference da ஆனா closed circuit la. Okay, internal resistance na the resistance provided by the electrolyte, which is happening inside the cell. Okay, now ipo vandu discuss panna poradhu enna, so let us say idudha cell. Usually we will be representing a cell like this. Okay, battery, now what we will do, we will mark multiple cells, adudha battery. Okay, ipo vandu in any of the question, if they have mentioned about internal resistance, if it is not mentioned, forget about it, we don't want it. Okay, ana internal resistance specify pannitena, we should draw the diagram like this. The cell vanda ippadi irukum, cell and adoda internal resistance. Okay, so the potential difference across these 2 points, let me say A B. Okay, potential across A B, adudha if it is open, adudha idoda EMF. Okay, adudha idoda EMF. Now I am connecting an external resistance now R. So ipo vandu what will happen, I current will flow, so there will be a potential drop will be there, and the potential drop enna IR. correcta purinjudha. So right now what I'm doing, now I have a cell with an internal resistance R. So ipo vandu idoda EMF E. Now I am connecting a potential difference, connecting an external resistance. Ipo vandu in the resistance capital aata. So we can say that due to the current flow, here there will be a potential drop, that is nothing but V is equal to IR. Adudha in the terminal voltage. IR. Okay, so in the point la irukra potential difference enna nu keta, that is nothing but IR, this V. Okay, ipo vanda if the current is flowing in the circuit, okay, inga oru resistance irukku, internal resistance, there is a potential drop, adu vanda IR. Okay, so ipo we can just write it as EMF minus IR. Okay, otherwise I can say that the EMF, the battery had an EMF. It is utilized for two purposes. One in the external resistor, next one the internal resistance. If we are rearranging this, I will be getting IR, or else I can just write IR, which is equal to V. In the relation one the romba important. If you have any confusion, you can ask me. Otherwise it is going to be a bit difficult. Purinjida. Terminal voltage vanda in the point la irukra voltage da when there is an external resistor connected to it. Okay, so ipo vanda the flow of current vanda ippadi. So in the flow lala inga oru potential drop irukum, and the potential drop vanda IR, and இங்க ஒரு drop இருக்கும் அது வந்து IR. இது ரெண்டும் sum பண்றதுனால we will be getting the EMF. Okay, the total நீங்க provide பண்றது E தான். Okay, the total we were just giving that nothing but E. Okay, அது வந்து split இருக்கு. First one வந்து IR, second one வந்து in the internal resistance. Okay, so now we are going for series and parallel combination. So series வந்து easy da. Okay, cell in series is very easy. So let us say we have cells like this. இது வந்து E1, இது வந்து R1, இது வந்து E2, இது வந்து R2. இப்படிதான் நம்ம circuit. Okay, getting it everybody getting it? Yes or no? Now we know that this is a series connection. So the potential across these 2 points A and B வந்து V is equal to the potential drop due to this one, அது வந்து V1, and this one is nothing but V2. Okay, I don't know, I was taking class and few students were saying like around 12 it was open. Okay, getting it or what everybody? Yes or no? I think it is. As I mentioned, I don't know, I was in the studio taking the class. After this only I'll think about it, because there is no such compliments for one who have done immediately, no, right? Okay, so இப்போ வந்து you just relax and you just watch the class. Okay, அதுக்கப்புறம் maybe it came, as I mentioned, I'm not aware about anything, I was in the studio, I didn't even had any connection. Okay, so இப்போ வந்து you have to do one thing, just focus on this class. இதுக்கப்புறம் we can check, or otherwise even if you are applying tomorrow also it's fine. Okay, don't be too late, that is the only thing. Understood? All good everybody? Yes or no? And likes missing arka, you should like more. Okay, so now we can just see that V is equal to V1 plus V2. Ipo vanda we can just say V1 na E1 minus I R1. Series na the current will be same. Okay, the current flowing in the circuit will be same, plus E2 minus I R2. Okay, now we are just making some rearrangement. E1 plus E2 minus I R1 plus R2. Done. Series is done. Okay, series is done. So ipo vanda we need to know V is equal to E equivalent plus minus I into R equivalent. So just compare this equation as well as this equation. So ipo vanda equivalent EMF na it will be coming as E1 plus E2. R equivalent na it will be coming as R1 plus R2. Resistance vanta as usual how we are doing it. And the madri same. So series na R1 plus R2. Ipo vanda we have many such cells. Okay, appo vanda what we will be getting? This is for 2 EMF, right? 2 cells. Ipo vanda if we have n cells, the equivalent EMF vanda E1 plus E2 plus etc En. If these are all identical. Okay, if these are all identical. அப்போ வந்து இந்த equivalent EMF na n into the EMF of one cell. Next one the R. Okay, so R equivalent na R1 plus R2 plus etc Rn. If it is identical, R equivalent which is equal to n times R. I hope you guys are getting it. Yes or no? Yes or no? Series is done. Okay, we have n cells. If it is identical, we will just add it. Next one, parallel. Okay, so in the parallel we are connecting the cells like this. Okay, so this is how we are connecting the cells. So in the case if it is parallel, potential same da, potential same da. And second case na, the total current I is equal to I1 plus I2. Now we should know the how we will be writing I. I na inna? We know E minus IR, which is equal to V. Am I right or wrong? So now I can just write E minus V by R, which is equal to I. Can I write it like this or no? Yes or no? Yes or no? So now I1 in the branchula, I2 in the branchula. So now I1 I will write it as, okay, I1 E1 minus V, potential same tha, so you can keep V divided by R1 and plus E2 minus V by R2. Okay, now we are dealing it separately now. We will be just divide individually with R1 and R2. So E1 by R1 minus V by R1 plus E2 by R2 minus V by R2. Okay, now we need some rearrangement. So E1 by R1 plus E2 by R2 minus V into 1 by R1 plus 1 by R2. This is what? This is what? I. Correcta? Correcta? We need V is equal to E equivalent minus IR equivalent form. So, adakaga, what I'm going to do, this is equal to I. So, next step okay, we can just cross multiply this E1 by R1 plus E2 by R2 minus V into R2 plus R1 divided by R1 R2, which is equal to I. Now I'm taking I this side and V this side. So we will be getting E1 by R1 plus E2 by R2 minus I, okay, minus I will be equal to V R2 plus R1 divided by R1 R2. Got it? Yes or no? Yes or no? Understood till this? Any confusion so far? Please let me know. Okay. So next one, what we need to do? We need V only in the left hand side. Okay, we need V only in this side. So adakaga we can just multiply this side with R1 R2 divided by R2 plus R1. Am I right or wrong? Yes or no? Tell me guys. So now we are going for it. So this one will be coming as ER2 plus E2R1 divided by R1 R2 into R1 R2 divided by R2 plus R1. Now minus I R1 R2 divided by R1 plus R2. In the case Lavanda, this will be get cancelled. So now we are just writing the format here. E1 R2 plus E2 R1 divided by R2 plus R1 minus I into R1 R2 divided by R1 plus R2, which is equal to V. V which is equal to E minus I R equivalent. Am I right or wrong? Yes or no? Tell me yes or no. Okay. Understood till this? Now we have V in the left hand side. It is safe. IR equivalent also. Okay. Because we just need to prove it, right? We need to prove how the relation, the equivalent EMF and R equivalent is coming in the parallel connection. Okay. Okay. So now what happened? We got V, I into R equivalent. The rest is just this part. For that, I'm just going to do one thing. We have E1 R2 by R1 plus R2, okay, plus E2 R1 divided by R2 plus R1, okay. So we are just giving individually, okay, we are just doing it individually, and this is what the E equivalent, okay. So if you need to write E equivalent, E equivalent, what you will write? E1 R2 plus E2 R1 divided by R1 plus R2. Okay, done. And R equivalent in the parallel connection the R equivalent the R1 R2 divided by R1 plus R2. Yes or no? Everybody got it? Yes or no? Okay. So this is what we need in the case of the parallel connection. So if in the case if we have identical, okay, identical EMF na or identical cells na, we will be just write E equivalent by R equivalent, because if we are just dividing the sorry. Okay, if you are writing E equivalent by R equivalent na, we will be getting E1 by R1 plus E2 by R2. Like this way we will get it. So if it is N identical cells na, it will be coming as N into E by R as the ratio. Okay, individual if you need to find it, you will be going for the equation which I have given. Okay guys, so let us just take a 5 minutes of break. Okay, I am having some issues with the throat. Just give me 5 minutes. Let us just take a small kutti break. Okay, so we will be come at what time? 3:35. I think now it is 2:58. 3:05 we can just come back. Okay. So everybody's here. 1 more minute is there. You are here, just say hi. So I'll also get to know. Okay, Damodaran. Okay. Yeah. So now we are continuing this one. So we were just discussing about the what our cells in parallel and series. So now we got the relations as well. So that is very, very important. We can expect the cell combination questions. So not much harder one, but still it is there. We will do few questions, so you'll be getting the idea. Okay. So now the thing is, like, let us say in the parallel connection, if we have the connection is like this. Okay, connection is like this. So the thing is, like, you can just see at this terminal both one is negative and another one is coming as positive. Okay, so in the Madri question vandena, what we will do, we will just subtract, right? In the EMF, when we are finding the EMF, we will go for minus sign. Okay, E1 R2 minus. Okay, but when it is like this, okay, when it is like this, we will go for when it is like this, we will be going for E1 plus E2. Understood? Got it? So that is the only thing which we should. For the resistance, there is no plus minus. Whatever be the equation, the same. Okay. Next one, the electrical energy. What is the electrical energy? Can you just give me an idea in the chat box, please? What is electrical energy? What is electrical energy? The work done by the battery is actually stored as the energy. Okay. So when the current is flowing through the circuit, it will be producing a lot of heat. Okay. A lot of heat. And on the heat one, there will be equal to I square RT. Okay. So in the equation one, the romba important. Okay. Unit one, we can just go for joule. Okay. Now this equation, as I mentioned, important. We can have questions also. Next one, if you want, you can just rewrite I in terms of V as well, because we know I is equal to V by R. So you can just substitute and you can just find it. I, V, T, all the equations will come. Okay, V square by RT. So you can go for it. Next one, the power. In power, what will happen? Power na energy per unit time. Okay, energy per unit time. So in the power one, we will be getting I square R. As I mentioned, you can just go for V square by R as well as IV. Okay, so these equations one the important. Now, idoda important topic we are going to discuss now. Okay, in the junction rule, loop rule, it is very, very important. At least one question, most of the year it was there. Okay, and usually one the high weightage questions in the junction rule, loop rule one the very, very important. Okay, so appadina junction rule na if let's say I1 current is coming, I2 current is coming, appadina the current which is going out from the junction will be equal to I3, that is nothing but I1 plus. So simple, we can go for an expression that the current entering into the junction, equal to current leaving the junction. So that is what I have written. When I1, I2 current is coming into the junction, the current leaving the junction will be the sum of it. Understood? So this is based on law of conservation of charge. Okay? That's what important, the conservation of charge. Junction rule is based on conservation of charge. Okay? the charge, the current, which means flow of charges, the charge coming to the junction is equal to leaving the junction. So in the 2 points ரொம்ப important தான். Next one the loop rule தான். In the loop rule it is based on conservation of energy. Conservation of energy. So idhula vanda the total, okay, the total potential difference across a closed loop vanda 0. Okay, the total, the potential, the sum of the potential difference in a closed loop will be coming as 0. Okay, this is simply the conservation of energy. Okay, conservation of energy. The total work done in a closed path will be 0. Work done per unit charge da in the potential. So adanala we can say the sum of the potential in a loop, in a closed loop vanda 0. Sum of all will be coming as 0. And one important thing, your application is out. I mean, you can just start your registration. I have just checked. So it is open. So those who want it, you can do it today itself or either this week itself. Okay, don't be too late because there will be a lot of issues may come, as well as we don't know like what are the situations that we are going to face. Okay, so if you are just keeping it late, maybe if any due to any reasons, maybe we can't. So don't do that. Please do it today itself. Not if it is not today, at least in this week. Okay, and the documents, everything I have. I mean, we already mentioned it. Major we have 5 documents now. Adella vanda we have done a separate video. I'm not going to do it here. Okay, so again, like marakada, share marakada, subscribe. You should do it. Okay, so now we got the loop rule. So loop rule la vanda the sum of the total potential difference vanda 0. Okay, so ipo vanda we have a circuit like this. Okay. So in the Madhya circuit vandana, how we will be doing that is very important. As I mentioned, it is high weightage. Okay. So if vanda very simple tha. We can't just simply determine what is going to be the direction of current here. Okay. So first thing is we will assume in this way only it is going. So for example, I am just taking like this. The current is flowing in this way. Let us say current I is flowing in this way. So it will flow like this. There will be a potential drop across here. It will reach here. இப்போ வந்து என்னாச்சு, yes இதுக்கு 2 branches இருக்கு. So I am assuming some I1 current is flowing here. Okay, I1 current is flowing here. So definitely total வந்து இந்த junctionல reach ஆன current வந்து enter ஆன current வந்து I1 தான் இங்க இருந்து leave ஆக போற. So what is going to be the current which is flowing here? Can you give me an answer now, please? Of course, this class is meant only for CBSE boards. We are conducting morning classes for the Neet batches. Okay, J kuda we have another channel. This channel is focusing on Neet. Okay, ma'am. Yeah. So now this is I. So idu vanda I minus I1 according to junction rule. Purinjida? Yes or no? Yes or no? So ipo vanda in the I1 current will be flowing like this. And you can see that I1 will be reaching here and this I minus I1 will be flowing like this and it will reach us here I minus I1 and again here it will be same I plus I minus I1. Okay, so ipavanta we will be getting I again here. Okay, so now conservation of charge is ready, or let's say junction, we have applied the junction rule. Okay, this is very basic thing. Understand, first one we will choose a path. Okay, don't think about which one will be producing current from which direction. We choose as it. Okay, so first step I have decided. If you want, you can decide from here. No issues at all. Okay, we are not bothered about which one is giving, I mean, what is going to be the direction of current. Nama choose pandra direction, the direction of current in the case. Okay, so na ippadi da direction choose pannirukken. So at this junction, in the junction la vanda current split ஆச்சு, and அந்த split ஆனதுக்கு அப்புறம் the current வந்து I1 in the branch la, I minus I1 வந்து in the branch la. Again, this will come to this junction, again the same current. Everybody understood? Yes or no? Can I get a yes or no in the chat box, please? Because idu vandu romba important. Each and every line is important. Adnalatha I am telling this. Okay, Damodaran, very good. Others, please respond. So, yes, third party. Okay, so we have decided the direction and we have splitting the current, and now we know what is the amount of current which is flowing in each circuit. Okay, we are going to deal two loops. Okay, in the case we have two loops. I'm going to focus on the first loop. So, in the case I can choose. So, we already made the direction like this. We already made the direction of current like this. இப்போ எனக்கு ஒரு direction choose பண்ணலாம். Clockwise, anti-clockwise, எது வேணாலும் choose பண்ணலாம். So, right now, நான் clockwise தான் focus பண்றேன். Okay, clockwise தான் focus பண்றேன். So, இப்போ let us say, this is what our cell. Okay, in the cell. Okay, so I current flowing. இப்போ இது clockwise நால. Okay, I mean we are going to deal this one loop. Actually current இப்படி flow பண்றேன். இப்போ what I'm going to do, I'm just choosing clockwise. So in the it will be, the current will be flowing in this way. So இது lower potential இருந்து higher potential போகும். அப்படினா இது positive. Okay, இதோட EMF let's say 6 volt. Okay, so அப்படினா இது plus 6 volt. Next I'm focusing on this resistor. இந்த resistorல என்ன ஆக போற? இப்போ the direction, the current ஓட direction plus இப்போ நாம choose பண்ண clockwise direction, both are same. Am I right or wrong? Am I right or wrong? In the direction of current, the clockwise direction we chose, both are same. Same na, the direction which we choose for the resistor, this is how the current is flowing, and we are choosing it as clockwise. Appadina current ippadida poga poradhu. Same na, idu negative. Okay, so let us say current is I, R1 is the resistance, minus IR1. Okay, now I'm just focusing on this branch. Okay, in the branch you can see that again, since we are taking clockwise, current oda actual direction, the direction we chose for the loop also in the same way. So that is again coming as minus, let's say this is R2. Okay, now we have this one. Okay, again current oda direction clockwise, so we will be going for minus IR3, which is equal to 0. Understood? So this is how we will be dealing the loop. So now we have to go for the problems. Before that, the Wheatstone bridge, it is another application of this Kirchhoff loop rule. So here we have 4 resistors and 1 galvanometer over here. Okay, this is having a potential difference as well. So first of all, the thing is like, let us say the current is flowing like this. This is I, this is I1, and this is I2. And here, from here, some current IG will go here. So I1 inga vanda current, the IG is reduced. So now it will coming as I1 minus IG. Okay, so that is how the current, or let's say we can just simply write I3, I4. Now I will tell you, this is R1, this is R2, this is R3, this is R4. If this Wheatstone bridge is a balanced bridge, okay, or the balancing condition is R2 by R3, which is equal to R1 by R4. Okay, R2 by R3, which is equal to R1 by R4. If this condition is satisfied, there won't be any current flow through this. Okay, there won't be any current flow through the galvanometer. அப்படினா ஏதாச்சும், I mean like you have 3 resistors, அதுல வந்து ஒரு resistor unknown தான், அப்படினா you can find the unknown resistance. Unknown resistance. புரிஞ்சுதா? So Wheatstone bridge oda concept வந்து very important because we can expect the questions. So இதுல வந்து balanced condition என்னன்னா R2 by R1 R2 by R3 which is equal to R1 by R4. And the condition satisfied now, there won't be any current flowing through the galvanometer. So then you can find the fourth resistor, the unknown resistor. So we are going for the questions. Let us do the question. Okay, I hope everyone aligned with this. A voltmeter of resistance. Voltmeter order resistance வந்து 998 ohm is connected across a cell of EMF 2 volt, internal resistance 2 ohm. The potential difference across the voltmeter and also the terminals of the cell. Estimate the percentage error in the reading of the voltmeter. So basically we need to find the potential difference. Okay, so the given data, the external resistance was the 998, the EMF was the 2 volt, internal resistance was the 2 ohm. So now how we will be finding the potential, the terminal voltage. Can you find it? What is going to be the terminal voltage? What is the equation for terminal voltage? V is equal to E minus IR. V is equal to EMF 1 to 2. I we can find it, right? So what is going to be I? Can you just give me an idea about I? I will be coming as V by R equivalent. So in the case of the R equivalent will be both this resistance. So potential in the EMF 1 the 2. So we can just go for 2 divided by total resistance will be 1000. Got it? So this is what 1 by 500 the current. Okay. So 1 by 500 into 2 will be coming as the internal resistance. Okay. So we will be getting like around 0.4. So this is going to be the internal resistance, sorry, the terminal voltage. Okay. So we got the terminal voltage as 1.996. Okay. Simply we have done we have substituted in the equation E minus I by R. So I we have to find, I will be coming as the EMF divided by the equivalent resistance. So we have substituted and we got. Okay. Don't forget to like, guys. Okay. Now we got the potential. Next one, we should find the percentage error. Percentage error equation is delta V by V into 100. So delta V na it is coming as 0.004. Correct. Initially, the EMF was the 2. Terminal voltage was the 1.996. Appadina, and the difference is nothing but 0.004 divided by original was the 2. Okay, into 100. So this is the percentage error. Understood everybody? Very good third party. Super. Okay, understood? Let us go for the next question. 2 identical cells of EMF 1.5. Okay, 1.5. EMF 1.5. Internal resistance R are connected parallel, providing a supply to an external circuit consisting of a resistance of 7 ohm, each joined in parallel. A very high resistance voltmeter reads the terminal voltage of the cell to be 1.4 volt. Okay, calculate the internal resistance. So in the question one, the delta V na we have studied percentage error in units and measurements, right? Units and measurements la percentage error kandupidikkiradhukaga we will be going for delta V by V into 100. Okay, and the change in voltage la irukra change adu divided by original into 100 the answer. Okay, percentage error oda equation purinjada Edwards. Okay, so ipo we were just going for the diagram first. I will tell you what happened now. We have 2 identical cells connected parallelly. Okay, so this one the first one, this one the second one. Okay, so this is what the cells. Okay, EMF koduthirukke, that is 1.5. Adukapro, what is happening now? Now we have another two resistors which is having a value 7 ohm connected parallel to each other. Okay, and after that we got a terminal voltage. Okay, the potential across this two is coming as 1.4. Okay, 1.4. So I will mark the values given. So this is 1.5. This is 1.5. This is what we need to find. Okay, either one the 7 ohm, either one the 7 ohm. So first of all, we can just make this to be very, very. We can find the equivalent resistance. Either one the 7 na equivalent resistance and equivalent resistance, equivalent internal resistance. Sorry, external resistance one the 7 by 2. Correct. Parallel connection da, so we will be getting 7 by 2. Okay. Now we have two. We have this thing. What to say? Our EMF and the internal resistance. So we will be going to find the value for it. Which equation we can use? Which equation we can use? Tell me. So we have EMF minus IR, which is equal to V. Appadina EMF minus V, which will be coming as R if we are doing divided by I. I'm just going to write. I know V is equal to IR. Appadina, I'm going to substitute this EMF minus V into EMF minus V divided by V into R, because I is equal to V by R. So I'm just substituting it, which is equal to R. Now EMF value is given, that is 1.5. V value is given 1.4 divided by 1.4 into 7 by 2 the nama R equivalent. In the R equivalent value this one. Okay. Now we have to find this R equivalent. Can you find it? R equivalent value, R equivalent. Once we got R equivalent, we can simply go for the internal resistance. I will tell you how to find it. Check again. Find the R equivalent value. Do the calculation. Do the calculation. Everybody do the calculation. 2.5 or 0.25? So it will be coming as 0.25. Okay. So if we got R equivalent order value, we got it. Now R equivalent we have two internal resistance connected parallelly. Okay, we have two internal resistance connected parallelly. Very good. So appadina this values are equal, identical. Appadina R equivalent na enna? Can I say R by 2? R equivalent one is 0.25 into 2 will be giving you R. 0.5 the answer. Understood na? Give me a thumbs up. Or I will explain one more time. If you have any confusion with this question, please let me know. If you understood, please let me know. Otherwise, we can explain this answer again, because it's an important question. Mostly repeated question. Okay, fine. So, if இப்போ வந்து the EMF ஓட value is given. EMF is 1.5. Okay. அப்படி we have two cells and the external resistance வந்து 7 ohm. That is also connected parallel. Now I'm going for the diagram. இது வந்து cell. அதோட internal resistance. இது வந்து the identical, the other one, internal resistance. இப்போ வந்து we have the resistance which is connected parallelly. Okay. So இப்போ வந்து இதோட value 7, இதோட value வந்து 7. This we don't know. இது வந்து 1.5, இது வந்து 1.5. Terminal voltage கூட we have, that is 1.4 volt. Okay. So இப்போ வந்து I'm just focusing on this part. Okay, I'm focusing on this part. Two resistors connected parallelly. So in the equivalent resistance வந்து 7/2 because parallel identical. Okay. And இங்க வந்து two internal resistance இருக்கு. We know internal resistance when it is connected parallelly, what we have mentioned, the value வந்து R1 R2 divided by R1 plus R2. இப்போ இது வந்து like identical now, we can just say R/2. Okay, or R by N. இங்க two resistors தான் இருக்கு. So R equivalent வந்து R/2. So now we can just write R equivalent வந்து R/2 and external resistance வந்து 7/2. Understood this till this, everybody? Understood till? Any confusion till this? Please let me know. Please let me know. Any confusion till this? We have found the internal resistance oda equivalent resistance and external circuit external resistance irukka adoda equivalent resistor we have found. Okay. Now we have the equation E minus IR which is equal to V. So E minus V by I வந்து R equivalent. Okay. R equivalent. So இப்போ வந்து we will be having I is nothing but V by R. So I'll be writing V by R. R will be coming on the top. இதுதான் நம்ம R equivalent. Okay. EMF oda value is given as 1.5 minus 1.4 divided by 1.4 into 7/2. That is what R equivalent, which is equal to R/2. And the R/2, while we are doing this calculation, we will be getting 0.25. So in the R one, the 0.5. Understood now? Yes or no? Yes or no? If it is okay, give me a thumbs up. Give me a thumbs up, please. So now let us go for the next question. So, romba important question. Okay, we need to find the potential difference between these 2 points. Okay, potential difference between B and D. Idukkaga what we will do, we will go for loop rule. So everyone should do with me. Otherwise, there is no use of watching this and finding it. Okay. So now, இப்போ வந்து இது positive, negative, இது வந்து positive, negative, positive, negative. Okay. So, இதுக்கு வந்து ஒரு internal resistance இருக்கு. அதோட resistance வந்து 1 ohm. இதுக்கு இருக்கு அது வந்து 2 ohm. இதுக்கு இருக்கு அது வந்து 1 ohm. And for this, that is 3 ohm. Okay. So, இதுதான் நம்ம complete structure. இதுதான் நம்ம complete diagram. And as I mentioned, whenever we are doing the loop rule, first one we have to decide we will be going for a current direction as per our convenience. Ipo vanda I will be doing like this. So in the current vanda, let us go for this one. Okay, current vanda flowing like this. Okay, and inga vanda it will be splitting. Fine. So I'm assuming the current which is flowing here is I. Okay, current vanda idla pass பண்றது வந்து I. Once it is reaches here, I வந்து split ஆச்சு. இது வந்து I1 and the current which is flowing here will be I minus I1. Till this anyone is having confusion, please let me know on the chat box. Just we are choosing the current direction. Current வந்து இப்படி போய் இங்க வந்து two branches இருக்கு. I split ஆச்சு I1 and I minus I1. Okay, junction rule da. Okay, junction rule na enna? Current entering and leaving must be same. அப்படினா I minus I1, it is flowing like this, it will come here. I1 வந்து இங்க இருக்கும். Again the current which will be flowing through it will be same as I. Done till this? Okay, இது வந்து ரொம்ப important. இப்போ வந்து we are going to decide two loops. This is my first loop and this is my second loop. இப்போ வந்து I am going for the first loop. First loop la I will be going for anti-clockwise. Anti-clockwise na I will be going like this. Okay? So இப்போ வந்து நீங்க பார்த்தேனா if I am going for anti-clockwise, இது வந்து lower potential to higher potential. Lower potential to higher potential na அந்த potential வந்து positive தான். So இங்க வந்து 3V positive. Okay? அப்படினா it will be reaching here. So current inga higher potential to lower potential. Higher to lower na that one will be coming as negative. So it will be coming as 1. Okay. Ipa vanda we can go for the resistors. First resistor vanda ippadida. The current which we choose and now the direction is anti-clockwise. Appadina in the resistance and the direction ore direction da. Appadina we will go for minus. The current we will be write it as I and the resistance one the 3 ohm. And looking at here again the same scenario is happening. Okay, same scenario is happening. So minus I into the internal resistance is 1. Okay. இப்போ வந்து we are going here. Current வந்து I1 and the direction we choose that is also in the same direction. அது வந்து minus. So minus I1 into 2. Okay. And the sum will be equal to what we said, it is coming as 0. Okay. இப்போ வந்து we have 3 minus 1 is 2. And minus 3I and I, which will be coming as 2I, minus 2I1, which is equal to 0. Appadina I can write 2 is equal to 2I plus 2I1. So I'm just dividing it with 2. Okay. I will be getting 1 is equal to I plus I1. This is the first equation. Okay. Sorry. Inga vandu 4I. Minus 3 minus 1. So minus 4I. Okay. So this will be 2I. Understood? The current is same from both the cells, man. Where? This one is I, and this one is I1. Okay. In the current in the cell level, the same, the I1. I have marked this one, I and I. I current resistance 3 into 1. Inga 1 into I. Okay. So inga I2 into 2. Sorry, I1 into 2. Sorry. Okay. So this is our first equation. Now we are going for the second loop. Second loop again I'm taking anti-clockwise. Okay. So I'm starting from here. So in the cell the lower potential to higher potential, so it will be positive. Now in the cell higher potential to lower potential, that is 1. Okay. So inga we will be getting lower to higher 2 and inga higher to lower 1. Now I'm just focusing on the resistor part, internal resistance. Okay. So if you are just checking it, you can just see that the resistor order and the current we chose as well as the anti-clockwise direction both one the same. Adinala adu minus. Current I minus I1, resistor 2. Okay. Now I'm focusing on this internal resistor. Idilum same the current order direction, the direction we choose all are same. Adoda negative the current I minus I1 into resistance 1. Now we have to go for this one, and what will happen? Okay, what will happen? Current order, whatever be the direction we chose for current, it is here. Okay, and in the direction வந்து opposite. அப்படினா இது வந்து positive தான். Positive na இது வந்து resistance to current வந்து I1 which is equal to 0. Understood? Daily PYQ sessions, it is actually going, small sessions are planned, it will come. Okay, don't worry. Okay, done. Of course, 18. From the Sunday onwards, we will be having daily physics class. You don't want, you don't have to worry about it. Adinala da nan sonna, you should subscribe the channel. Then only you will be getting the new notification. You will be get updated. You will be coming on time and we will rock. Okay? Okay? So, marakama like panniko, subscribe panniko, share panniko. Friends also should study. Understood? Iduvarekku ellarkum purinjiducha. Okay? What we have done? We first chose a direction for current. அது வந்து ரியலா இருக்கணும்னு ஒரு it is not necessary at all. Okay? And second வந்து we have chose the direction of current. அதுக்கப்புறம் we will be deciding which are the loops we wanted to. We will be going for the loops. அதுக்கப்புறம் வந்து the direction of the loop, anti-clockwise or clockwise, and also the direction of current. Same na we will go for negative. Opposite na we will be going for positive. Okay, so idu varaikkum purinju. We will be going for expanding this. So now 2 minus 1 the 1 minus, we will be having 2i minus 2i, minus and minus will become plus. So we will be getting plus 2i1. Okay, then we have minus I plus i1 plus 2i1, 1 the 0. Okay, okay. Now you can just see that I'm just writing 1 minus 2i minus I. Okay, so we will be getting this is what these are the I terms. So we will be getting minus 3i, and in we have 2i1 plus i1 plus 2i1. So we will be getting 5. Yeah, we will be getting plus 5i1 which is equal to 0. So now we can just write 1 is equal to 5i1 minus 3i. This is what our equation number 2. Okay. Now we got two equations. You got 3i plus i2 is equal to 2. Maybe I have done some errors. Yes or no? Check it again. I minus I1 into 2, that will be negative. Again minus I1 into 1. Then again plus 2I1. Okay. Now you can just compare equation 1 and 2. Okay. You should compare the equation 1 and 2. So if you are just doing this, either I or I1 you have to cancel. Okay, either I or I1 you have to cancel. So for that, I think we can just multiply it with, you can just multiply equation number 2 into equation 1 into 5. Okay, so we'll be getting 5 which is equal to 10i plus 5i1. So now you are just checking on this, you will be getting 1 is equal to 5i1 minus 3i. So now if you are just subtracting this, what you will be getting? This side we will be getting 4 and 10i. Okay, 10i minus 3i. So we will be getting 7i. So we will be getting 4 by 7 as I. Once we get I, we can go for finding I1. You can substitute in any of the equation. Okay, you can, okay, fine. Okay, so you can just choose any of this equation. You can substitute and you can find I1. Once you get it, the potential will be coming as I1 into 2 is the answer. Okay, hope everybody got it. I too don't know whether I have done any mistake in the calculation. Okay. I think somewhere I also made some mistake, some calculation, but you should do the proper calculation. Again, I don't want to do it. Okay. So now let us go for the next question. Calculate the value of current drawn from 5-volt battery in the circuit. So first of all, the thing is like you should find R equivalent, because for current I is equal to 5 divided by R equivalent. So if you are just checking on the diagram, what you will be getting, you can just see that. So here you have this 10 ohm, this one, and here you have 5 ohm, okay? And then connecting this two, you will be having this another 10 ohm, and again we have 20 ohm, and here we have 10 ohm. So this is a Wheatstone bridge. Now you should check, is this a balanced one or unbalanced one? So balanced one, we can just see that this 10 by 20 should be equal to 5 by 10. So that is true. It is coming as 1 by 2. It's a balanced one. So you can just find the R equivalent. R equivalent now, if this condition satisfied, which means there is no current flowing through this. So now you will be having 10, 20 in series, 5, 10 in series again. So that will be coming like this. This is 30 and this one will be coming as 15. So these are the two resistors. Okay. So again, this is what you are not attending the class continuously. That is why we will do PYQs. Okay, we will do PYQs. And this is again parallel. So you can just find it and you will be getting the answer. Okay, so this one R equivalent will be coming as 30 into 15 divided by 30 plus 15. So this will be coming as 450 divided by 45. So that will be coming as 10. Okay, so 10 is going to be the R equivalent. So 5 divided by 10 is the answer. Okay. So now I'm going to give you a question. Okay. Find the magnitude and direction of current in 1 ohm resistor. You should find the current and magnitude, direction and magnitude of this resistor. This is 1. Okay. This is 6 volt. This is 3 ohm. This is again 3 ohm. This is 2 ohm. And this is 9 volt. Okay. And there is no internal resistance. So again, as I mentioned, you will be going for the loop rule, and you should find the answer, and you should give me the answer in the comment box as soon as possible. Okay, so this is what we are going to do, and PYQs I will be doing in the separate session, don't worry. And every day from now onwards, I think the PYQ classes, the most important question series will be updated, so you don't have to worry about that as well. Also, as I mentioned, I want to get the answer for this question in the comment box. Please try to do it and give the answer as soon as possible. Okay, and Kirchhoff law, the questions I will be doing separately, because that is very, very important. Today I'm feeling really tired, and also I have some problems with my throat, so I'm just winding it up. Okay, so fine, but we will continue with this, don't worry, and do the problems. Okay, otherwise you will be in trouble. Okay guys, see you. Bye bye. Thank you, Damodaran. Next class is going to be on Tuesday. No classes tomorrow. Neet class will be there for physics, and I think tomorrow you will be having chemistry or biology. Okay, not physics. Physics will be on Tuesday. Every day this class is there. Okay. See you guys. Bye bye. Take care, and everyone should practice the questions. And whatever be the comments that you want to tell, you should comment on the group. Comment box. Also the answer for this question. Don't forget. Okay. See you. Bye bye.